Hi everyone. Can can you guys hear me? If you can confirm in the comment section.
Yes, we can hear you.
Yeah, so we're having a little issue with screen sharing and all that, and we'll be fixing that and we'll begin the event shortly. So please bear with us. Yeah, we'll be fixing it very, very soon. So please hang on. Thanks.
It has enabled a cashless economy where people make purchases with their faces. A giant network of surveillance cameras with facial recognition helps police monitor citizens. Meanwhile, some schools offer glimpses of what the future of high-tech education in the country might look like. Classrooms have robots that analyze students' health and engagement levels. Students wear uniforms with chips that track their locations. There are even surveillance cameras that check their phones or yawn during classes. These gadgets have alarmed Chinese netizens. Schools say it wasn't hard for them getting parental consent to enroll kids into what is one of the world's largest experiments in AI education, a program that's supposed to boost students' grades while also feeding powerful algorithms. 为了就是国家的这个研究呀、发展呀，我觉得是没有问题的。The government has poured billions of dollars into the project, bringing together tech giants, startups, and schools. We got exclusive access to a primary school a few hours outside of Shanghai. To see firsthand how AI tech is being used in the classroom. For this fifth grade class, the day begins with putting on a brain wave sensing gadget. Students then practice meditating. 现在想象我们眉心有一点柔和的光芒绽放。The device is made in China and has 3 electrodes, 2 behind the ears and 1 on the forehead. These sensors pick up electrical signals sent by neurons in the brain. The neural data is then sent in real time to the teacher's computer. So while students are solving math problems, a teacher can quickly find out who's paying attention and who's not. 说明这段时间他是有点在那走神的。A report is then generated that shows how well the class was paying attention. It even details each student's concentration level at 10-minute intervals. It's then sent to a chat group for parents. 就是他可以看到每个人的评分。The reports are detailed, but whether these devices really work and what they exactly measure isn't as clear. We were curious if the headbands could actually measure concentration, so one of our reporters tried on the device. This is a new technology with still fairly little research behind it. Theodore Zanto is a neuroscientist at the University of California, San Francisco. He was surprised to learn that this tech, called electroencephalography, also known as EEG, is being used in the classroom on children. It's usually used by doctors in hospitals and labs. EEG is very susceptible to artifacts. And so if you are itching or the EEG wasn't set up properly so that the electrodes didn't have a good contact, affects the signal. Despite the chances for false readings, teachers told us the headbands have forced students to become more disciplined.
Yeah, so guys, welcome to yeah, I know we've delayed a lot. So I would just like to welcome everyone to the event. I'm very sorry for the delay. It wasn't our intention. Yeah. So we'll be starting now. And yeah. So okay, I'm coming. Let me share my screen and we begin shortly. Okay. Okay, so if you can confirm my screen is on, can you guys see? Hello? Okay. Yeah, so I'm sorry for the delay. We'll be starting right now, and I want to welcome you guys to our anniversary event. So it's been 3 years. Can you guys believe 3 years of learning AI, of practicing and doing for the community? So this event is just to celebrate AI plus OAU. I'm sure we have guys from AI Plus OAU on the call. If you are from the community, I want you to send fire emojis to the chat room. Just flood the chat room with fire emojis. If you are from AI Plus OAU, no one. Yeah. Okay. I can see Peter. Okay, Peter. So only Peter is from AI Plus OAU. Yeah, okay. So without wasting much time, so we're beginning with a welcome speech by Bumi. So Bumi is also one of okay, I can see Precious, I can see Grace, Fire, I can see Samson. So welcome guys, and sorry for the delay. Yeah, so let's welcome Bumi. Bumi is a team lead. She has always been with the community from the start, and she just be giving you guys a welcome speech. What are you supposed to expect from this event, and what will we be serving you guys? And yeah, so just stay tuned. We have a lot in stock for you guys. We have giveaways. Yeah. So I needed to point that out. So we have giveaways for you guys. And we're not even giving in naira. Can you imagine? We are giving in dollars. Yeah. Okay. So Bumi on the call. Bumi. Okay. Yeah. Okay. So let's see. I think. Oh, sorry. Mm, okay. Okay. So I think the issue here is if the issue here is if we okay, I think I'm just going to go ahead and do that, and I think I've done that already. So we'll be having four speakers on the call this evening, and each of the speakers are going to share different perspectives of of what they see about what they feel about the field of data science and AI. Yeah, so please stay tuned, and I think we have a lot in stock for you guys. So moving on to the event proper. So before you even start at all, even if you are not from the community, I'm sure you want to know about the community. So AI plus OAU, who are we, and why do we even call ourselves AI plus? Okay, so I'll just be going straight to about the community. Yeah. So AI plus OAU, as you all know. So you may be wondering why it is AI plus. Plus meaning, you know, the regular genotypes. So can you give me a minute? Yeah, so sorry for the break in transmission. Okay, so I know our genotypes are A, no, is AB a genotype? Yeah, AB, AS, and the likes. But I think in our community, our genotype is AI plus. So meaning AI runs through our veins. So moving on, AI plus is a subsidiary of Data Science Nigeria. Data Science Nigeria is the biggest, and if not, yeah, the biggest and if not the only data science organization in the country. Um, so we are a subsidiary. So there are different AI clubs in different states and different universities. So this is just a branch of Data Science Nigeria on OAU campus. Um, we are a community with the sole aim of raising vibrant data scientists, machine learning engineers, AI engineers, and researchers from OAU. And the community originally started as Data Science Ife. So I know even on our group sometimes you say Data Science Ife, but it was Data Science Ife, then later transitioned to AI plus OAU in 2019 um, under the administration of Data Science Nigeria. So the community today is led by Paul Okeomi, yeah, my humble self, and Grace Omojola. Yeah, so Grace is also on the call. She's gingering me from the chat. Okay, so what's our aim and objective as a community? So one thing is we want to raise AI enthusiasts across OAU campus to leverage technology. Yeah. So I think that's one of the reasons why we found ourselves doing a lot of ML and everything, or doing a lot of classes. We want everyone to be empowered with the knowledge of AI. Yeah, two, we want to make AI resources and materials readily available to every student. I think that is possible. Yeah, so we want to spread want to spread and reach every student with AI resources and materials. Everyone interested, and I think everyone should be interested in AI because it's a very cool field actually. Next, want to expose members to building tech products via community projects and development. So as a community, we want to it has started already though. So we're planning on building projects um, that are going to be sellable and be marketable. So next, we want to bridge the gap between academic practices and industrial exposure. So because fine, there are a lot of things for example, I won't name any department actually. Okay, so there are different departments where you feel okay after now, what next? After studying this course, what next? Yeah, and it may surprise you or it may not surprise you that every field has some component of as AI can be applied to virtually every field. And having a community like AI plus OAU on campus, you can just contact us, and if you want to apply AI in whatever field you're studying in the school, we're always here for you. So that's just bridging the gap between academics and industry. Yeah, so our community profile, you can follow us on Twitter at AI plus OAU, um, our YouTube Data Science Ife, our GitHub is Data Science Ife, and Medium. Yeah, so we release articles on a regular, very nice articles for you to consume on our Medium page, AI plus OAU. And a little challenge before I move on, the hashtag for this event is hashtag AI plus OAU as three. I think I had that at the front. So this is the hashtag AI plus OAU at three. So the first person to tweet about this event on Twitter will be getting credit worth $2. And it sounds small, but $2 in our currency is actually about 1,000 naira. So first person to tweet about this event using the hashtag AI plus OAU at three gets $2 worth of credits soft. Okay, so community events. One of our first community events was the Clean Code Challenge. Yeah, so Clean Code Challenge is just although we do a little bit of algorithm challenge too. So Clean Code Challenge is just a challenge where we throw out data structures and algorithm questions, or basically ML algorithm questions, and attach a price to it and see who can come up with the most optimal solution. Speak AI. Speak AI is just one event where we bring in industry experts to speak with us, to tell us how the industry is out there. So because we are students and we don't have too much experience, so Speak AI is just events where those in the industry can come and tell us stories about how it is in the industry. Um, AI invasion. Yeah, AI invasion is also one very massive event that happens in cities across Nigeria, organized by Data Science Nigeria. So it happens in over 30 cities. I can't remember the number, but it also used to happen in Ife. Data Week is a free 7 day, is a free week. It's an annual event that happens for 5 days. That's 5 days a week, and it's always free, where we share the knowledge of data science and machine learning. That's the Data Week. And community hackathons, Zindi, Cargo, organized machine learning hackathons and the likes. AI Saturdays. AI Saturdays is one event where, yeah, Saturday events where we treat ML, we teach ML and data science. Yeah, so pictures of some of our events. This is Data Week 2019. Yeah, so that's Data Week 2019. So you can see someone through the projector. We had a guest speaker from KPMG talking to us about data science. So we got to invite Kenji. I don't know how many people know Kenji. Kenji is a very, very, very big data science person on YouTube. Yeah, so we invited Kenji to speak with us, and it was a very, very massive event. We had people from across Nigeria and even outside Nigeria. Yeah, so these are stuff things we do as a community. Yeah, so let's talk a bit about our achievements and awards. Yeah, the list is quite long actually. Yeah, so in 2019 at the AI Bootcamp organized for data scientists across Nigeria, 2019, yeah, out of about 560 participants, we out of about 760 candidates um, on the leaderboard, um, we had 40 members who were part of those who were part of who came top. So we had no, sorry, we had 24 members who came top. 250 people were selected, and we had 25 people. So this was a very massive thing for us because we had the second highest number of participants at the bootcamp. Um, I think that followed the following year. I think okay, Team Solo. Team Solo is one of our Team Solo consisting of my humble self, Dunsin, and Paul. Yeah, there was Umojak Nigeria happening for data scientists across Nigeria. For data scientists across Nigeria. So it was a very massive event actually, and we managed to come second at the Umojak Nigeria. It was involving universities across Nigeria also. Yeah, Umojak Africa 20, this is 2020 also. No, 2021, that was this year. Team Solo from our community also came forth representing representing OAU globally. Yeah, that's across Africa. Different campuses across Africa participated and managed to come forth. Can you imagine? Yeah. And shortly after that, our women. So it's not only the guys that are doing stuff, the ladies are also doing a lot. Tosin Akintibu and Grace Omojola, deputy lead, they came first and third place respectively at the Women Hackathon organized on Zimbi. Yeah, so these are exploits we've been making over for a while now. And yeah, so the very big one. Okay, this is not the biggest, but then we are going. Okay, so at last year's boot camp, we won a series of awards actually. One of them was the award for best poster. So this award is just for research work um, done by the community, and we had over 20 participants. We had over 20 teams, yeah, and we had two teams out of the 20 from OAU. And one of our teams, Plantnosis, we came first. We won the best poster award for that year, and we also won. So Plantnosis is just an AI tool. Probably it sits on your phone and it does the plant disease diagnosis. Yeah. Okay. So myself and Precious Kolawole were awarded the award for Mr. Ami's algorithm for those that contributed, those that are doing a lot to contribute to the ML community in their own capacity. Yeah. So moving on to the big one. Yeah, the big one. At that same event, at the same boot camp, we won the award for AI School of the Year. Yeah, so probably I forgot to chip that thing. In 2019, we lost the award by because we had 4 people short of Unilag, and 2020, fortunately for us, we won the award, and we're given AI a million naira worth of AI resources. So this is one very big achievement for us. So the award presentation was done early this week. Yeah, that was on Monday. So as you can see pictures from the award presentation, then the books were given, and if you can see, you see we have a Raspberry Pi then. So like just shows that we are going to be exploring a lot edge ML on edge devices, ML on mobile, ML on web. We're doing a lot with these resources we've been given. So I don't know why you won't join us as a community. Yeah. Okay, so one thing I want to point out is after seeing all this I've listed out and you feel you want to be part of us or you don't even know how to get started, we're organizing an event, ML with Python training. This is going to be starting tomorrow. Yeah, this is going to be starting tomorrow. And I'm promising that this is really going to be awesome. It's going to be an awesome experience for everyone who attends. So there are going to be two tracks. One is the beginner track. Beginner track is just introducing you to the Python programming language, because most of the time we use Python in the field of ML and data science. Yeah. So and then the intermediate track is introducing you to data science and ML proper. So if you have basic understanding of Python already, I guess this is the track for you. So to get started in the field of ML already. This is happening tomorrow at PY 102, which is physics oven. So we won't be having at PY 130 due to some issues we have with the venue, and it's not going to be running concurrently. So beginner track is going to be starting by 9 and ending by 11, while intermediate is going to be starting by 11, ending by 1. So if you want to join, feel free to message me or Grace. I think I'm going to be dropping the details in the chat section. Yeah, so I don't know, was I convincing enough? Was I able to convince you that AI plus OAU is a community for you? Yeah, so you can join now. It doesn't cost you anything to join. I'll be dropping a form in the comment section for everyone who is a student of OAU or alumnus of OAU who wants to join the community and join us to build beautiful stuff. Yeah. Um, okay. I guess that is where we'll be ending the introduction. Okay, so moving on proper, we'll be having our first speaker. We're having our first speaker, Stephen Oni. Yeah, sorry. We'll be having our first speaker, Stephen Oni. And sorry, we'll be having our first speaker, Stephen Oni. But before I introduce Stephen Oni, there's something I want to do. I don't know, for guys that are using Airtel. For guys that are using Airtel, we have fastest finger recharge card for you guys. So I don't know. I want to know in the comment section, are they guys here with using Airtel, using Airtel, and are you guys ready for fastest finger? Once I see someone indicate in the chat section, I'll start calling the numbers. No one using Airtel, or they don't want our card. Okay. Airtel users, no Airtel users. Airtel users, drop a fire emoji in the comment section. Once I see one fire emoji, I'll start calling the number. Okay, so the number is 1049 1974 8791 4599. Does anyone get that? Shall I call it again? 1049 1974 8791 4599. Yeah, so I guess we have one lucky win. I don't know. Did anyone get it? No one. Okay, Kolade got it. Yeah, Kolade said yes. No. Okay, Kolade didn't get. Kolade didn't get that. Okay, so Oseni Sakariao got that. Yeah, that was Ethel. So moving on quickly, I'll be introducing Stephen Oni. Yeah, so Stephen Oni will be talking to us today about data science and software engineering, how to thrive. Stephen Oni is a prolific software engineer known to have built an open source data science library. And he dwelt among us. Okay, sorry for the breaking down session. Simeoni is a prolific software engineer known to have built an open source data science library for JavaScript developers called Danfo.js. I don't know how many people know Danfo.js. Yeah. So Stephen Oni is a co-author. He's currently a software engineer at Datopian. It's called Focus on Building Data-Driven Tools. Interested at the intersection of ML and the web. Also, and he's also into privacy AI. He's currently running his postgraduate studies with the African Institute of Mathematical Sciences, AIMS, Senegal. And he's very passionate about sharing his tech journey with young techies. Yeah, so Stephen Oni is around. He's one of the panelists already. Yeah, so I don't know if you can hear me.
Yeah, Paul. Yeah, I can hear you.
Yeah, so
Yeah, thanks for the introduction.
I don't know if I did justice to that bio, but
Yeah. Yeah.
and
So
I
it's
don't know
even
if I
more.
should greet you in French since you are not in Nigeria, Senegal. Yeah, so I think you can take the floor now.
Okay. Yeah, thank you very much. So hi everyone. As Paul described, my name is Stephen Oni. I'm a software engineer and also a machine learning engineer also. So can you guys hear me? Hello. Okay. So Paul has described everything about me. So Stephen Oni, software and machine learning engineer. So I'm currently interested at the intersection of ML with the web, bringing tools from the Python ecosystem to the JavaScript ecosystem. And one of those tools, Danfo.js, which is like pandas for your JavaScript developers, and also tools like dNotebook, which is like Jupyter Lab for JavaScript developer, and some other tools for features engineering to make features engineering quite easier for JavaScript developer. So I'm glad to be here. So I don't know if Paul can permit me to share my screen. So is it possible to share screen? Yeah.
Yeah, you can go ahead to share your screen.
Okay.
Stephen, do you have difficulty sharing your screen?
Okay, yeah. I think I will need to quit Zoom now, then rejoin. So I need to set some system preference here.
Okay. Go ahead to do that.
Yeah, just give me some minutes. I'll be back.
All right.
Okay, thanks.
Okay, so while Stephen is setting up his Zoom, did anyone get our card? No one. Should I call it again? Okay. Someone got the other card already. Sorry, I forgot that. Okay. So Glow users in the house, are we there? Glow users, I need just okay, Bumi. Bumi doesn't need card, Jerry. I'm not giving okay, Bumi and just two people. Okay, Samson is also a Glow user. Glow users in the house. Okay. So I'm going to be calling this very fast. Very fast. Fastest finger. Are you guys ready? 97931 18815 50870. Did anyone get that? Did anyone get that? Do we have a winner? I'll be calling it again very quickly. 97931 18815 50870. Okay. So Stephen is back. I guess we can continue. Okay. Okay, I'm coming. Let me try to.
Okay, guys. Can you hear me?
Yeah, so Stephen, can you go ahead to share your screen? Okay, yeah. Steven, I think your mic isn't on. Can you check?
Oh, sorry. I'm very sorry for that. So let me go back again. So can you see my screen? Hi, guys. Hi, guys. Can you see my screen?
Yeah, we can.
Oh, okay. So I said I've described myself earlier on. Steveni, software and machine learning engineer. I'm strongly interested at the intersection of web and machine learning and privacy AI. So to find more about me, you can check this website below. That is my portfolio website. So today I want to discuss about data science and software engineering, how to thrive. So the main idea of this topic is how you as a data scientist, how you can benefit from the knowledge of software engineering and how you can use this knowledge of software engineering to make your life easier, to make you do your work effectively and efficiently. So as a data scientist, we know for every project we have to do, maybe in a machine learning competition or for a project, the first thing we do is we do data injection, data cleaning and transformation, data model training, model testing, then prediction. Then we keep adding data sets, keep cleaning the data set, features engineering to make to get the perfect model. So, but the reality is, on the machine learning system, or the machine learning system pipeline is far bigger than this, and it's far broader than this. So this is the reality. So your ML code is just a small part of the whole system. We have all other things to it, like your data collection, configuration, monitoring, service infrastructure, machine resource management. But you know, this field is quite demanding, and some job application will tell you, oh, we need a machine learning engineer that is good with some DevOps skills, no Kubernetes, no Docker, no this and that. But for today's topic, we are not actually discussing all those technologies. The main idea is how can you use the knowledge of software engineering from this other part of fields that is required for a machine learning engineer to understand. So how can you use this to write better code, to do experimentation, to make your experimentation faster? So why? So why do you need to have the knowledge of a software engineer, even the basic knowledge of it? So the first one is fast and reproducible experimentation. So I know some of us have participated in machine learning competition, where while in the competition, there's a starter code. You use a starter code, make some edits to it. You do some different kind of experimentation. And while trying to, at the end, maybe you become the first, second, or third, and you're told to submit your code for review. You'll see sometimes you're not able to reproduce the exact notebook that give you the same score that is on the private leaderboard. And sometimes you want to do competitions that are similar to previous competition you've done before. Then you find out that you start copying different codes from different places. You open your previous Jupyter notebook, start copying some code from features engineering. But with the knowledge of software engineering, you'll find that there are some functions that you're using every time. There are some things that you kept doing every time. So having this knowledge of software engineering, you can know like, oh, I'm supposed to make this a particular function. I'm supposed to create this kind of abstraction, and it will make your experimentation faster. Let's say maybe you want to do something and you have a code base that is very structured. You can easily go to that code base and do what you have to do. So let me use myself, for example. There's this recent competition I participated in that is for image classification. So I've done that kind of competition before, and the code was well structured. So instead of me to find code online, trying to structure my code base, trying to do this, the experimentation was very fast because I just need to change the input, which is the data, and the same thing, the same process, the same cells, the same notebooks makes everything very easier for me to do. So having the knowledge of software engineering, writing reusable code, modular codes, having good knowledge of the programming that you're using, for example, Python, you can write more efficient code that are very fast. So, and that is what software engineering will do for you. So also we have experimentation production. So the knowledge of software engineering will reduce the thin line between experimentation and production. So as a data scientist, sometimes you do experimentation on Jupyter Lab or Jupyter Notebook. And at the end of your experimentation, you go to VS Code, start copying some code from Jupyter Notebook, start arranging them, formatting them. That is extra work. But with the knowledge of software engineering, there's a way you can make your experimentation code, which is the code in your Jupyter Lab or Jupyter Notebook, to be similar to your actual production code. So there are some tools like NBDev, which is produced by the first year guys. Like, when you are doing experimentation on Jupyter Lab, there are some cells that you run experimentation on, and there are some cells that are the original code itself. So with ideas from software engineering, there's how you can convert the most important cells to the actual code. So it makes the line between experimentation and production to be very thin. So you can easily do your experimentation and at the same time you are writing the production code. The third reason is zooming out. So having this knowledge of software engineering will make you to be able to interact with other people that you'll be working with. Sometimes you'll be working with a DevOps engineer, you'll be working with the back-end engineers or the front-end engineers. So if you have basic knowledge of this field, you can easily interact with them. You can easily interpret what you are doing to them, and it will even give you a better way of writing your code to make life easier for your colleagues, which are backend engineer and the DevOps guys. So how can you, what are the specific knowledge that you need? So the first one, I would say programming skills. For example, in Python, for example, in Python, if you have a function that is always doing a particular thing, maybe you have a function that whenever you put an input, it will give you, let's say, an addition of that function, maybe 2 plus 2. So if you've computed 2 plus 2 before, and let's say 2 plus 2 is highly computational, like the computational stuff is very intensive. So instead of computing the same thing every time, so if the input is the same input, there's how you can prevent that function from performing that computation. It just takes the result of the former computation and output it for you. So having this knowledge of the in-depth knowledge of the programming language you are using will make you write better codes and to make your code cleaner. So the second one is writing modular and reusable code. So there are some functions that you will realize while doing your data science work, the functions that you're using every time, the same process that you're doing every time. It is better you learn to create some modular functions or create some abstraction so that whenever you're trying to do any other project similar to that project, it will make everything very easier for you to do and it will aid your experimentation. So we have version control. So I don't know if any one of us we are familiar with Git and the likes. So version control makes you it will make your experimentation quite easy because sometimes as a data scientist, we can use one notebook for different type of experimentation, changing things, tuning this model, tuning that. And what most people does is they create different notebook for different experimentation. But with the proper knowledge of version control, there's how you can save different copies or different experimentations, and it will make you to easily maneuver your way between different experimentation, and it will make your code reproducible. So testing. So we have what we call CI/CD. We call it continuous integration and continuous development. So what's the use of continuous integration and continuous development? So while doing your data science work, you might have a model that is giving you 98%. And when doing your experimentation, you try to make the thing good. Then you make some changes. Then after those changes, maybe you want to push to production. Then if you have a good continuous integration and continuous development system, it will check if the current model that you just created is better or the same thing with the previous accuracy or the former model. So if it's not good, it will revert. It won't merge your code with the code that is on production. Also the same thing for your data. Maybe before you are using data that contains columns like dog, cat, different features. And for your new implementation, the data set is not containing any of these things again. So sometimes you might not know. You might just push if you don't have good CI/CD, you can push this into production and everything seems to work well and you won't be able to catch the error very fast. But having a proper testing, it will make things very clear for you before pushing into production. So the fifth one is using terminal. So I don't know, most people are using Windows For Linux for Linux users and Mac OS users, you'll be familiar with the word terminal. So there are some things like you don't actually need to write Python code for. For example, you have a CSV file, let's say about millions of rows, and you want to quickly check what's this schema for this data. Instead of you trying to run Jupyter Notebook, trying to call pandas, trying to read the CSV file, you can easily just open your terminal, write some basic commands like add the CSV file, then some other things to get the first 5 rows of that data set and see what is there. So also there was a time I was trying to move some files around. So I was using these annotation tools for object detection. So after annotating those images, the way the image was scattered in the folder was very bad. So the first idea was, okay, open Jupyter Notebook, get some Python's modules like globs to arrange these files. So instead of doing that, the first thing is just to open terminal, run the command for copying and moving files around, and everything was just fast. So having the knowledge of terminal makes your works very easy and very fast. And the sixth one, containerizing using Docker. Sometimes you perform some experimentation on your system, and those experimentation is working fine. The packages are well installed. You are getting a good result. And when you try to share your work with your colleagues, is having issue with installing some tools, having issue with getting the same accuracy as yours. But with the help of Docker, it's possible for you to like create an environment which is shareable. Like this environment, you can transfer it to your colleagues and also get the same results as you want. So the knowledge of Docker is very good as a data scientist to have. And the seventh one, which is cloud service. This is quite optional, but sometimes you might end up not being so specialized if you have to work in some places. You might end up deploying models. You might end up trying to manage your models that is being deployed. So having some knowledge of cloud service like AWS, Google Cloud, will make things very better. And also having this knowledge will be able to make you to communicate with other developers like the backend engineers, the DevOps guys. You can easily share knowledge with them. So the next one. So is that all? So what I in the previous slide, these ideas or these things that I listed are just some basic and the fundamental parts of the software engineering skills that you have to have. But there are some advanced ones. But as you go on to master these fundamentals ones, you begin to discover some other ones that you need to master on your own. So this field is very wide, like I said earlier, and it's very demanding. You might see like you need to learn this, you need to learn that, but the main idea is to just go slow. Just be steady, be consistent at what you do, learn the things you need at the moment, and as time goes on, if you are consistent enough, you'll see like you keep acquiring more knowledge and keep getting better. So I think that is all for this slide. So thank you.
Yeah, so Stephen, I want to say Stephen, I want to say that was a very, very awesome speech. I'm sorry, an awesome presentation. I don't know, but personally for me, I I learned a lot because even talking about Docker is something that everyone keeps talking about, but isn't that easy to learn. So Stephen is asking us to be consistent and and take it slow like a snail. So no rush. Yeah. So I think I enjoyed the session. I don't know about you guys. If you really enjoyed Steven's session, I want you to send your favorite emoji to the chat room. I think I have. Peter is very excited. He's sending a lot of emojis. Yeah. If you're someone like me that it took you so much time to learn Docker, you probably want to You want to thank Stephen for acknowledging that you should take it slow and not be too hard on yourself. Yeah. Okay. Some guys were saying the Peter so did I say Peter? Peter, stop entering my head, I beg. So someone was saying Glow wasn't the Glow code the Glow this thing I called wasn't valid. Was that true? Yeah, the Docker part is for me. Yeah, Derek. I think a lot of people find Docker very challenging sometimes, but probably as you get to work with it more. Yeah. And yeah. Okay. So moving on. No time to waste time. No time to waste time. Um I said the Glow I called, someone said it wasn't valid. Is that true? Glow users in the house. Glow users in the house. So I'll be calling the Glow again. I don't know. So lucky, yeah, someone said it wasn't valid. So Glow users in the house, I'll be calling the code again. For guys that want to check it, that want to dial. So dial the number you're supposed to dial, star whatever, star 123, I think. Yeah. Um 97931 18815 50870. I'll call it one more time and move on. 97931 18815 50870. Yeah. So we've had our first speaker of the event. We've had our first speaker of the event, and I know you guys are hungry for more. Actually, you're hungry for more. But before then, yeah, I said the first person to tweet about the event using the hashtag gets $2 worth of recharge card. This is about 1,000 naira, and I'm just seeing only 2 tweets since we started the event. Okay, so I'm going to be increasing that. So the first 2 people to tweet about the event, the code is still invalid. Okay, forget about it. Yeah. So the first 2 people to tweet about the event um using the hashtag AI plus OAU at 3 gets 1,000 naira worth of card each. So forget about the Glow card. We are moving on to 1,000 naira worth of recharge cards. So I said the first 2 people to tweet about the event using the hashtag AI plus OAU at 3 gets 1,000 naira worth of recharge card each. So yeah. Okay. So we have our next speaker in the house already. Our next speaker is Opeyemi Bamigbade. Our next speaker is Opeyemi Bamigbade. So before we even move on, someone is saying, can we get the link to the Zoom meeting for others? Yeah, so I think Bumi should handle that. So Bumi, can you send the link to the group? Can you send the link to the group again? Can you send the link to the group again? Okay. I'll be sharing my screen now. I want to introduce Okwe. So Okwe, I don't know if Okwe is here with us. Okwe, if you're here with us, um unmute yourself?
Hi, Paul. Yeah, I'm
Yeah,
here.
Okwe is actively here with us. Yeah. So quickly, I'm going to be introducing you guys to Okwe. In the comment section, I want you guys to welcome Okwe. Welcome Okwe. You can type in that or send in your favorite emoji. Yeah. So I guess you guys can see my screen now. Okay. So Okoyemi is a data scientist, a machine learning and systems engineer with over 3 years of experience. Wow. In end-to-end data analytics projects ranging from data collection, exploration, transformation / wrangling, model building, deployment into production. Oh, that's a lot. He's also done large and small scale projects ranging from predictive, prescriptive to descriptive modeling, recommender systems, churn modeling, computer vision, and natural language processing. So from Okwe's bio, Okwe is an all-rounder already. So whatever questions you're having for our panelists, please drop them in the comment in the Q&A section. So I think I have 2 questions here already. So Akwe is going to be talking to us about MLOps, a broad overview. So I'm sure the word MLOps, a lot of people have been hearing the word MLOps, sounding similar to DevOps. So I don't want to spill everything though. Akwe will continue. Yeah, so I want us to welcome Akwe in the chat section. Yeah, so I'm guessing Akwe can take over now.
Thank you.
Yeah, I'll
Thank
keep
you
sharing
so
my
much,
screen.
Paul. Thank you
Yeah.
so much for the introduction. And yes, a shout out to everybody on the chat session. I'm very, very happy and delighted to join you this evening. So I'll go ahead and be sharing my screen now. Just a second. Please, can we confirm that we can see my screen?
Yeah, we can see your screen up there.
Okay, so happy anniversary to DSN AI Plus OAU once more. And
Thanks a lot.
So a brief introduction about myself once more. Thank you for the introduction. I'm just a machine learning engineer at Data Science Nigeria, passionate about integrating ML systems into larger systems such as web, mobile, and embedded systems. So in this interest, you will see that I use a lot of word around systems, right? So when it comes to MLOps, you have to think about MLOps as a system, right? But before we get into that, I would like to quickly do a quick introduction of where I currently work at Data Science Nigeria. Though I have probably like 15 minutes to finish this slide, but yeah, so I will just be fast about it, you know. So at Data Science Nigeria, as we all know, Data Science Nigeria is a non-profit organization, and with a vision of having 1 million AI talent in 10 years. And I believe that majority, if not 100% of people on this call, on this session right now, we are we are part of this vision, and we are part of the 1 million AI talent in 10 years. So part of the figures that we are proud of is that we've been able to share over 17,000 offline contents for out of reach individuals that we believe that might be having some challenges getting top-notch resources out there. So we've been able to deliver on that end. We also have been able to share over 1 million plus artificial intelligence book for starters, free book to download. And we also have our YouTube channel where we have a very interesting number as well, over 95.2K subscribers and the views. Okay, so on that is just part of our achievement. I would like to go into presentation mode so that, okay. Now, local capacity building on data science and AI application for social good. We've done a lot of work around that as well. So as part of our recognition, we merged #1 artificial intelligence learning community solution delivery network in Africa, where we won the Matai Award at Deep Learning Indaba 2019. We also won the best poster award at 21st ACM conference, economics and competition. Also, we had recognition at the largest artificial intelligence hackathon, Tunisia 2019. And we are so privileged to have our founder speaking engagement at the world #1 scientific artificial intelligence platform at the US. Also, we run the biggest free AI learning platform on the continent across campus, cities, online. And I'm very, very sure we are aware of this. So I wouldn't like to bore us more about the company. So I'll just move straight to what we have today. And yeah, I'm very, very sure that AI Plus, AI Plus OAU is also part of this fantastic AI Plus campuses in Nigeria, right? Okay, these are wonderful, awesome stuff. Also, we run business analytics and training at the hub, free university students, and the likes of it. Okay, and you can also try to get the first artificial intelligence book for primary and secondary school. All right. Now, if you want to know more about the company, you can check www.datascience. You can check the website, you can tweet, you can check the Facebook page, or you can just call the phone number. Yes, so what we have today is MLOps overview. And to actually understand MLOps in this context, you have to see it as a productionalizing machine learning model, right? Everything about MLOps is just you building a product around machine learning. Now, if you think of machine learning as just your normal sklearn and tabular data only, I guess you are getting it wrong, because machine learning is everything you know about ML, you know about DL, you know about computer vision, natural language processing. All these things around AI is simply called machine learning. You understand? So we're going to look at machine learning model development, MLOps versus DevOps, which is very, very important. Then deployment options. We're also going to look at architecting production ML systems. And probably, if time permits us, we might look at post-deployment activities. So let's deep dive into this. Now, we are all familiar with this, our basic categories of machine learning: supervised, unsupervised, and the likes of it. Also, when it comes to machine learning model development, you have to think of it from the perspective of a machine learning engineer, who sees every bit of the project as a system based on the end product you are looking at. So you have to see everything as a system. So the first part of the system is always the data injection. How does data come into my system? Okay, now the data is inside my system. What am I doing to the data? Am I splitting it, or am I training a model on it, or am I making prediction on the data? From there, you start thinking, okay, fine, I can achieve certain things on the data. So how can I train at large scale? That is, how can I predict at large scale? How can I train at large scale as well? That's another system. Then you can also start thinking of, okay, fine, rolling out the prediction and the likes of it. Then how to monitor and everything. So if you look at every piece element of this slide, you see that I've broken everything down in what? In system. And if you're able to identify that every piece of this project is what? Is a system, then you'll be able to create a wonderful project that can scale and can be linked to another project, right? Now, this system can be very dynamic depending on the kind of data you're working on. If I'm working on tabular data, I can rearrange this system to suit what I want. If I'm working on image data, sound data, or anything, it changes, but we still have a general overview that whatever we are doing in MLOps is a system, right? Okay, that being said, we can also look at machine learning model development. And this is where MLOps starts from. You have to look at it from the research and the development phase and the develop and integration stage. Now, the research and the development phase, you have nothing to do about that if you are just an ML engineer. We believe that this is a work of research and data scientists where they gather the model and they build fantastic model out of the data. But your job, the output of research and data scientists is just what? Insight and saved model or pipeline. You'll be glad if they can give you a saved pipeline, right? So, but as a machine learning engineer, whose core work is basically nothing more than MLOps, right? What you are required to work on will be application source code, user interface, user input processing, testing, validation, deployment and automation, monitoring what is happening after deployment. How do we even upgrade this model afterward, after deployment? So your output as a machine learning engineer in MLOps will be what? APIs and what? ML-powered applications, be it mobile application, web application, embedded AI, and the likes of it. So the output of MLOps will be what? ML-powered application. I want us to get that right. Okay. Now, I just put this as part of a research and data scientist role. What we expect of them is what we expect of that research and data scientists, our job role is to give us a saved model in any of this format, whether TensorFlow saved model, HDF5 for Keras, PyTorch, and Pico for basic Python from sklearn, Onyx, and the likes of it, right? Okay, now this is what interests me the most, right? When it comes to MLOps and DevOps, although we have the differences, but the differences are not up to the similarities. Now, if you look at MLOps, don't be deceived with just few headers here that MLOps is a subset of what? DevOps. No, at some point you can say that, but also if you look at it from another perspective, you see that they're trying to achieve different things. Just that part of what MLOps is trying to achieve must be achieved in what? In DevOps. That is certain. Now, if you look at this, if you follow me and look at this, you see that the beginning of this is to start with what? You're starting with the design. After designing, you test and train. Then after training, you deploy. And once you deploy, you maintain. That is everything about what? MLOps. But when it comes to DevOps, you start with what? The planning, the code, you build, you test, you release, you deploy, you operate, then you what? You monitor. That's what DevOps is all about. So if you're looking at these two images, you will see that you can say that MLOps is a subset of what? Of DevOps to some extent. But if you move to the next slide, this is a typical MLOps workflow. It starts with production and ends with production. What do we mean by production? We assume that your model is already in production now. But what then do you do after production? You identify, before you get to production, you identify, you collect, you process, and store data, right? From there, you can now think of what? You explore, you extract, you train, and you optimize the model, right? From there, you can think of, okay, the output of that is an optimized what? Model. Now that I have optimized model, then I plan, I develop, I package, and I test. Once this test is passed, then I'm in a staging what? A staging phase. So the staging phase, then move to what? We release, we configure, we monitor, and what? We validate, and we are back to what? Production. And this cycle continues like that. Why does this cycle continue? The cycle continues because of data drift. A model trained probably like 10 years ago might not be relevant again at this point in time. So we have to keep doing this. And that is why it is called what? An operation. An operation is meant to be continuous, right? So if you look at this definition, we can say that DevOps principle also applies to what? MLOps. But there are some aspects of machine learning workload that require a different focus. Now, if you think of it, that what are the aspects of machine learning workload that require a different focus? Of course, the data part of it, the collection of data, the processing of user data is totally different from what you're doing in DevOps. If you have done something around DevOps, what you're doing in DevOps is you're probably signing the user in, you're giving them access to some database and the likes of it. But when it comes to MLOps, what you are doing is you're collecting the user data and you're returning back a prediction or a prescription or an insight. Right? So there are two different things, but you can look at them in some similar perspective as well. So if you move ahead, I don't know how much time I still have. If you move ahead, you can see that the objective of MLOps aims at managing and deploying all types of machine learning model at large scale production environment. But in DevOps, it aims at merging development, quality assurance, operation, and what? Deployment and integration into single continuous set of what? Of processes. You see that the objectives are kind of different and similar in some way, right? Now, when it comes to team skills, you should, in an MLOps team, you are expected to have research scientist, data engineer, machine learning engineer who serves the role as a software engineer in DevOps, right? But when it comes to DevOps, what you have is software engineers, software developers, cloud engineer, and architect, right? Also, when it comes to development, in MLOps, is more experimental and iterative. Yeah. When it comes to MLOps, you have to think of everything as an iterative process because what you are doing is iterative. You are collecting user data, you are probably training on fly, or if you're not training on fly, you're predicting on fly, isn't it? So, and that processes are what? Are repeated. So it is what? It is experimental and iterative. But when it comes to DevOps, it is linear with less degree of feedback loop because it is just a straight road. Get the user sign in, give them access to some database, let them utilize your product and log out of the system as well. That's how it works, right? Now, the testing, I can keep going and going, but I need to quickly move to another slide now. But where we have the intercept is what? Is at production. When it comes to production, ML model is continuous and can be more challenging than traditional software because when you're trying to deploy a machine learning model, you are not only concerned about the output, but you're also concerned about the what? look at it from the fairness of your AI model, because whatever prediction you are giving to the user becomes what? A decision support system for that particular user, right? So it is not a fixed or an expected output of 2 + 2 = 4. No, I have some features, and based on your features, you are eligible to take this loan or you're not eligible to take this loan. Okay, I can label this as a bed or this is a computer, depending on the task you're working on. So at production, you have to be very, very mindful of that. Okay, now when you're coming to deployment options, there are several deployment options. And at some point, I got overwhelmed about deployment options. Like, it depends on the client. What does the client want? What does the company want? What does the user want? So you can deploy ML as a service. What does that mean? A decoupled system. Like I said from the beginning, everything is a system when it comes to what? MLOps. You are deploying as a service, which serves as what? A decoupled system. In this case, you can choose to deploy as just API, right? You just build the model and you expose it via API. You're not building any front end to it. You're not building any other thing to it, but you're just exposing it as what? As API for any other system to consume, right? Also, you can also think of it of publishing it as a package. You can publish it, package it as a package, and what? And push to probably like something like NPM packages and the likes of it, right? Also, another deployment option you can think of is what? You're deploying as a full system, like as a what? Tightly coupled system. What does that mean? ML as an app or what? Embedded system. You're deploying as a standalone web application. That is, everything the user needs is in that system. Both the ML and the user interface tightly coupled together, right? Or you're deploying as an embedded AI, maybe in a Raspberry Pi or some other, micro components, right? Okay, that's fine. Now, when it comes to deployment option again, you can think of the overview of the ML architecture in 4 different ways. There are more than this, but try to simplify it to 4. You can train by batch and predict on fly. What does that mean? You train for probably the company has given you data from probably like 2002 till 2020. You train on that batch, then you predict on fly. And when you're predicting on fly, probably your system can give just one output at a time. Think of it like a banking system that you apply for ATM, then you get what? Your ATM back. But when the bank is applying to maybe other assisting companies that are helping them to produce the ATM, they will give it to them in batch, right? And they get it back in batch. But when you are getting yours, you are getting it as a single ATM, right? So that's what we mean by training by batch. We are predicting on fly, and you can serve that via what? REST API. Also, you can train by batch and predict on batch. What does that mean? You can have a system whereby the input is not just for a single record, but you can upload a file into it and get prediction for almost probably like thousands of users at the same time, right? Also, you can also think of train and predict by streaming. This one is very, very challenging to actually, and very, very challenging and resource demanding when it comes to ML architecture, because every data comes into the system, let's say like every seconds, every 5 seconds, you're getting the data from the system, you're retraining the model on the system data, and you're predicting immediately, right? In that case, you know the amount of data that you'll be consuming, right? Also, training by batch and predicting on mobile, probably on other client application, right? Okay, but I think you understand better when we come to this table. There are some downside and advantages of each of the pattern. If you're training, and the downside can be looked at in terms of training, prediction results, latency for the prediction, and system management difficulties, right? So for pattern 1, we said that we are training by batch. We are predicting on fly, and we are getting our prediction via what? REST API. But when it comes to latency for prediction, man, we can say that it is so-so, probably so-so, it is so-so. Then System management difficulty, yeah, it is so as well, right? But when it comes to pattern 2, a shared database in the sense that you're training on a batch, predicting on a batch, then the prediction is coming through a shared database. Since it's a shared database, then the latency for prediction is what? Is high. Because it's a shared database before it gets to the end user that needs the final prediction to start making decision. It has to go through a lot of hierarchical steps from the database manager and the likes of it before it gets to the final user. But the system management is very, very very, very easy because it is based on what? Database. Database has been founded and is grounded, right? But pattern 3, when it comes to streaming of data, streaming in the sense of you want to apply streaming mostly for recommender systems, right? Or you want to apply streaming to self-driving car and likes of it, right? You want to retrain on fly and get your prediction on fly. Stuff like that. When it comes to training streaming, prediction is also streaming, prediction result delivery, streaming via what? Probably like a message queue. The latency for the prediction is very low because you are streaming. Immediately the model finished training, you are getting the result immediately. So you are streaming. So and when you're streaming, the latency is very, very what? Very, very low. But the management of the system is the hardest. Very, very hard. Like very, very hard to manage what? A streaming ML system. For instance, imagine you want to integrate ML into Uber system or boat system, transport system. You know how difficult that would be to what? To manage on real time, right? Okay, so pattern 4 is you're streaming, but you're what? You're predicting on fly via maybe a process API on mobile, and the latency for that is low, and the streaming management is kind of so not too difficult, right? Okay, that's explained. Now, if you want to get some startup on deployment options, you can check this article, Deployment of Machine Learning Model Demystified. If you want to get more on that, on Medium, and this is the user name. Also, deployment option. Deployment option can also be looked from static and dynamic view. What do you mean by that? You have a client in the static part, you have a client, prediction request comes into your system. You look up in the table, then you get labeled, which has been what? Pre-computed. Example of that would be in probably like a chatbot, right? But when it comes to dynamic, you can have the client, send prediction, model runs on it, then label computed on demand. Can you get that? So in this case, you can be thinking of probably like a recurrent neural network in this case, right? Okay, now what are the differences between static and dynamic? High storage, right? For static, because you have to store every pre-computed labels. You have to store them. You have to, it's like an expert system. You have to think of all the edge cases, right? Then the low fixed latency, lower maintenance and space intensity. Of course, if I'm having high storage cost, then I should be having what? Space intensity. But when it comes to dynamic, we have it to be low storage costs, variable latency, higher maintenance, but compute intensities. Because why is it compute intensities? You are running the model on fly. But in this case, they have been what? They have been pre-labeled. You are just fetching from you're mapping on a table that has been pre-computed, right? Okay. Let me move to the next slide. Now, when we are architecting production machine learning system, when we are designing, the following should be borne in mind. It's very, very important. You have to think of modularity. What does it mean for modularity? The code used in processing feature engineering should be arranged in a comprehensive pipeline. From the beginning of the project, you have to think in direction of pipeline so that your code can be reusable. If the client comes tomorrow that I don't want this feature, it's just for you to go into the pipeline and remove that feature. But if you have coded everything, it means your project it will just crash. You have to start building from scratch again. So that's why we encourage what? Modularity in your coding. Then you also have to bear in mind reproducibility. Like your code should be reproducible. That is, you run the code today, is giving you a prediction of 4.5 degree. and tomorrow I should get the same result for the same data input. It should be what? Replicable. So if it is not replicable, then it means that your system is not stable. Maybe there are some random stuff that you've not taken care of, or you're generating some stuff on the fly that is dependent on another input from another system, right? You have to take care of all those edge cases. Then it should be scalable. The model must serve to a large number of customers, with minimum response time. I've sent requests into the system, I get my prediction almost in real time, if not real time, right? Because when it comes to like self-driving car, I want to get the prediction in real time because the car is driving itself. If it's not getting the prediction in real time and the monitoring in real time, that could end in a disastrous event, right? Also, we have to look at from perspective of scalability, extensibility, testing, and automation. Automation is very, very key because just imagine that you are going through manual process for an iterative scopy work. Your work is iterative and experimental, but the more you automate things, the more the iterative part gets more attention, and you get to spend lesser amount of precious time on manual labor, right? So you have to automate a lot of things. Just eliminate any manual process. Like for instance, your feature engineering should all pass through pipeline. Also, if I push to the control version, it should automatically deploy to production, meeting some certain specification. If my model accuracy passes probably like the previous one, 90, and the biasness level is very low, then you should push automatically to production. All these things should not be checked by what? Should be checked once by the machine learning engineer and automated for every other processes as well, right? Okay, now Steve Oni has done justice to this. Your ML code that you do in Jupyter Notebook, Colab, and the likes of it is just a tiny piece of the entire ML system. And the more the moment you realize that your ML operation is a complete system, then you know that, yeah, you have a lot of basic functional units that you need to put together to achieve what? A common goal. And the common goal you want to achieve is to serve what? To serve the end user the prediction that is expected. So you can think of it as production machine learning system is a conglomeration that is coming together, bringing together of what? Different functional units working together to achieve what? A common goal. And every unit of the system has peculiar outcome. The outcome of data collection is data. Data verification is verified data, and the likes of it like that, right? Okay. Now, when we are architecting production ML system, you can think of it as also the first thing to decide on is full cloud implementation. You can go in that way, right? Because we're not architecting. I've moved away from traditional now. We are architecting, that is, we are building a system for ML. Like, let's assume that a client has walked up to us now. Can you build this solution for me? So when you're architecting before you start coding, I should have all these things in mind. Would I like to go full cloud implementation? That is, both my training, my deployment, everything lives on cloud. Such tools can be GCP, Amazon, AWS, SageMaker, Microsoft Azure, and the likes of them, right? Or do you want to go hybrid? That is, I want to build part of it on my compute system that I have physically in front of me. Then I push to the cloud for utilization, right? Or I want to have on-site on-prem, that is on-site build and on-prem prediction. In that case, you have your system physically in front of you in a system. In a computer, and you're getting the prediction only from that computer. It means that you can't get the prediction out of that building. And where that is kind of useful is in the case of security-wise. Probably you're dealing with some kind of sensitive data and sensitive prediction, and you don't want to be exposed to cloud. Maybe you're not okay with Google GCP terms and conditions or AWS, or you don't trust version control. You want to have everything in an embedded system in your office. Then you should be going for on-site training and on-prem getting prediction of the kind of thing, right? So this will guide us on the kind of tools we want to use for the ML architecting. So once I know that I'm going full cloud, okay, I'm going full cloud, I should start looking at, okay, probably I want to use GCP, I want to use AWS. Am I going for hybrid? If I'm going for hybrid, wow, I have to set up my environment on my system. Then at the end of the day, probably I want to use Docker or Kubernetes orchestration and the likes of that, right? Okay, then if I'm going for on-prem, oh, we need to order for this supercomputer because we'll be training on-prem and we'll be getting the prediction on-prem here, that is on premises, right? So that's how it works. A typical ML system should comprise of the following components. I don't know if we can see this diagram very well. So we have to integrate the front end for the job management, monitoring, debugging, and the likes of it. Then we have the tuner, and this is where most of our work lies as an ML engineer, the data injection system, data analysis, validation, data transformation, and the likes of them until you have a pipeline storage, right? Okay, now also we're still on architecting production ML system. For effective architecting and implementation of the selected method, whichever method you've selected, whether full cloud, on-prem, or hybrid, there's a need to be current on the available tools, such as libraries, framework, and infrastructure. So you've chosen to go with hybrid. Yes, I should be setting up my TensorFlow environment on my system, or probably my PyTorch environment, sklearn environment. You should be familiar with the current version of things, and also the version available on your destination. What I mean by destination or target system is, at the end of the day, I'll be pushing to cloud. I have to go and check what do GCP support? Do they support what I'm using to train? Do they support what I'm using to test my model? Do I have these two available? So once I know that, oh, these are the pieces I have to put together, then once I put that together, then I have my ML production system. Not that you build your model, you build everything on version 2, but on the process of pushing to cloud, version 2 is not available for you on cloud. You have to now go back to the beginning and start retraining, start the whole process from the beginning as well. You understand? So you have to go from your end goal back to your to the starting point. Okay. Now, also on architecting, the level of automation of data science steps defines the maturity of of ML process. If your level of automation is low, it means that your ML system is rigid and it comprises of a lot of manual processes. And what we have been able to bring out of that is the maturity of your system. If there are a lot of automation, then the system is fully mature. But if you have probably like bits or 50% automation, then we can say that the system is a bit mature. But if everything is just hard-coded, you're getting the features, instead of you to pass it through pipeline, you're hard-coding everything, or you're not even doing any of those things. You're just doing some if and else. If it is this, give the user this response. If it is that, give the user this response. Then you're doing a lot of manual labor, right? So we've grouped them into 3 levels. Level 0 is manual process. Level 1 is you're using ML pipeline automation. Then tools around these are probably like a TFX and the likes of them, right? Then level 2, which is the highest of them, is continuous integration and pipeline automation. You understand? You have your CI/CD. Once I push into this, this is being triggered, this is done, and the likes of it, right? Okay. Right. So ML level 0, explaining ML level 0, you have your offline data. It comes straight into your data extraction and analysis pipeline. It comes to data preparation. Everything done here, there are manual experiments, which we do in you do in your Jupyter notebook, data preparation, data modeling and evaluation. Then you have your trained model. Then we drop it into probably a model registry, probably on the cloud, right? Then from there, we serve the model. Then we get to the prediction. The ML is everything here. The operation is everything here, right? So we have the experimentation, development, and test, staging, production, and reproduction, right? Now, the characteristics of level 0 is manual process, right? You have manual, script-driven, iterative process, disconnection between ML and operation, infrequent release iteration, because you've done version 1. Now you want to release version 2. You have to build it version 2 from scratch. because in version 1, you did everything with manual process, right? No continuous integration or continuous delivery. Then deployment refers to prediction service, only trained model instead of the entire system. It's only the trained model that you have as an output instead of your entire system being packaged as a what? As a pipeline, right? Also, we have lack of active performance and performance monitoring. Sorry, Paul, do I still have time?
I dropped a message already. I'm guessing you didn't see that.
Okay, I'll just round up now.
Right.
Yeah. Okay, so we have this also. Let me just move ahead to level 2, which interests me the most, right? This one follows the principle of CI/CD pipeline automation. You have your model analysis into your data analysis, then you have an orchestrated experiment that is fully managed experiment that reduces your manual labor, right? Then the output of that is your source code. You have your source code repository. Then you have a CI, continuous integration, that builds, test, package the pipeline. And out of that, you have your package. Then from there, it goes into what? CD pipeline deployment. Once I have my package, the next thing is to release. Then I move to stage 3, which is what? Deployment, right? Then from there, I can start thinking of what? Data extraction, validation, data preparation, model training, evaluation, until I get to what? Continuous deployment. In this case, I'm now moving from trained model into what? Into serving model. And at the end of the day, I have my metadata that is useful to what? All these processes that were formerly in my manual processing level 0. I have them as metadata and an automated pipeline. And I have a trigger here. The trigger in the sense that once certain conditions are met, all these things runs again. When certain conditions are met, all these things run by themselves, right? Okay, and at the end of the day, we have what? Predicting service. Okay, so I would like to also explain on this, but I have limited time. If you want to read more on production, building production ML system, probably for instance, Google Cloud Platform, you can check this out on Medium. Also, you might want to also have an adaptable ML system. What do you mean by adaptable ML system? For instance, the client has probably come with a view of probably 5 features initially, but in the long run, they came to realize that there is this important feature that should be added to your system to better improve the business case, right? At that point, do you want to start building from scratch? But if you have catered for that from the beginning and you have an adaptable ML system, right? Such improvements, such changes or unplanned changes can just easily come into your system without disturbing anything that you've set up already, right? That's just adaptable ML system, something that can adjust itself, right? Okay, now at the end of the day, we have to have our post-deployment activities. The model predictive performance is monitored, potential invoke, and the likes of them. I would have loved to explain more, but you can check all this article out on Medium to learn all these concepts in total. And yeah, you have data machine learning in containers as well. There are many of them there. You can check them out. Okay, I think if you want to connect, you can check GitHub source code with Kwemi Bami on GitHub and all this link to connect. Thank you so much. Paul, over to you.
Yeah, so amazing presentation, Okpeyemi, and so you guys can tell that Okpeyemi has wealth of knowledge in this aspect, and glad we had him over. And I'm sure you guys learned a lot from his session, because Okpeyemi can keep going and going if you don't even stop him. So I think he shared his contact already, and try reaching out to Okpeyemi and all the articles. I don't know, Okwe, will you be sharing with us your slides so that you can access the articles you referenced?
Yeah, I can do that.
Okay. So you guys should just chill, and the slides will definitely get to you. So once I get them, I'll share them on all the platforms that we shared the Zoom link to. Yeah. So personally for me, this after this presentation, what one thing that kept ringing in my head was, Paul, you still have a lot to learn. I don't know if that's true for everyone watching, but then this just points out that okay, yeah, um, this this is the way the field is, and this is what you have to learn in future. This is what you eventually learn, and just prepares us. So following Steven's advice, Steven said we should take it slow and be consistent. So I don't want you guys to feel overwhelmed and feel, oh, this is too much for me to learn. So just take it slow, and probably in nearest future you become a boss. So everyone enjoyed your session, okay? Thanks for coming around. Yeah. So guys had questions already. Guys had questions in the Q&A. Should I read them now? Yeah, I'll take a few of them, and I'll leave the rest to the rest to be I'll be asking the rest during the panel session after our final speaker, Elisha. Okay, someone is asking, as an ML ops engineer, how do you design and build systems that make predictions for real-time streaming data? I think you talked a little about streaming data. I don't know if you can just what do you have to say about that?
Yeah, thank you so much for that question. So that question, implementing a streaming system is not something you want to experiment with because you don't even have access to such resources, right? Take for instance, Uber entire system. You want to be getting live data from probably their drivers, and you want to predict to them, this is the location they should go to because of high demand, right? So you are dealing with a big system in that case. So it's beyond a data that can fit into your system now. You're fetching live from the database, it's running through your pipeline, and you're giving out your prediction in what? In real time. So you can think of it from that perspective that your database is changing with time. Your model is running based on the database, and your prediction is dependent on what is coming from the database in real time. But you can just set probably like a 5-minute or 10-minute recurrent running or iterative process in that case. I don't know if that answers your question.
Okay. Yeah. So can I if you have to give an example of a streaming data that updates in a constant time?
Yeah.
Is the stock market an example of that?
Yes, that's fantastic as well. That's a good one.
All right. Yeah. So I guess that answers your question, anonymous attendee. Yeah. There's some questions here I'll be leaving till our panel session. Someone is asking, when deploying a predictive model, particularly something on time series, what's your recommendation for validation and deployment? Let's say we are predicting global food price. That's from Oluwafemi Abiono.
Okay, I think you are being specific now, Oluwafemi. Maybe it's probably a project you are working on. That's fine. Okay. You are currently asking the what? The what? Can I get the question again?
So when you're deploying a predictive model, particularly a time series, what's your recommendation for validation and deployment?
Validation. Okay, fine. When it comes to time series, you're building your model on what? On past data, and you're trying to forecast into the future, right? Okay, now you have to look at the past series of data as well to think of, is there new trend coming up from my prediction? Or is it following a particular pattern in a particular season that has existed in my what? In my historical data? If it is something that is just coming out from, if it is something, an existing pattern embedded in your historical data, but you're seeing it in an exponential form or a sinusoidal form, then you have to look through it based on what you have in your historical data. But if the outcome is coming from probably like from your historical data, you are seeing some trend and it's not so clear, like this trend is so new, like it's not embedded, there's nothing like it before in the historical data I've trained on. Number one, you have to be very careful if your model is performing well. Number two, you have to put in some hypotheses to start checking, okay, if it is raining in July, does that give the spike for corn in the season or so? Why is this happening, right? So the validation will start leading to what? Hypotheses to be answered. So that's the approach you want to take.
Okay. So Femi, I hope that answers your question. Yeah. Okay, moving on. There's one more question here about asking about the Microsoft Azure Associate Data Scientist certification. I don't know if you took the certification. It's asking, will it help in learning ML ops?
Which one?
The Microsoft Azure Associate Data Scientist certification.
Yeah, actually, I haven't taken any of those, but if you have interest and you're passionate about those, you can take that, like the Microsoft Azure, the TensorFlow certification, and the likes of it. But what counts the most is why you're taking some of those certifications. Don't be driven by those certifications, but the knowledge you acquire during the process of getting the certification. You get it. So, but it will help, and it will greatly help in your ML ops career.
Yeah. So it's saying, more what it's saying is, don't just pursue the certificate. You probably want to just grasp the concept being transferred, and certificates can come after. Yeah. So the session was very awesome. Q&A coming after the panel session. More questions you're having, keep dropping them. I'll be noting them. And I've seen this question on NLP. Someone is asking. I'll ask it later on, but I guess we should proceed and move on to something, to the next. Yeah. So quickly, I'm guessing this is going to be a very fun thing on our program. So we're going to be playing a very, let's say, quick. Yeah. So I don't know. We are giving out 2,000 naira worth of credits, recharge cards, to the person who wins this session. So this is just a very simple game. I'll share my screen now, and yeah. So I don't know if you guys are ready for the game. Let me see emojis in the flood the chat section with emojis. Let me know if someone wants to win our 2,000 naira. No one. Shall I move on? Yeah. Okay. Yeah. Okay. So what you're going to be doing is, I'm going to show a logo. The logo is going to be from a framework or a library or whatever. Something you probably have worked with it in your data science journey. I don't know. So we'll be sharing a logo or a framework or a library, a logo of a framework or a library. Then the first person to guess what that is scores 1 point. So at the end of the session, the person that scored the highest is going to be rewarded. I don't know if everybody got that. So if you got that, respond in the comment section. Tell me, Paul, let's go there. Did everyone get the instruction? Okay, let's go there. Okay. So I'll be sharing my screen now. So it's more like a fastest finger something. When you see the logo, type in the framework that owns that. Okay, so I'm sharing my screen now. Jesus Christ. Okay. Yeah. So can you guys see my screen? Can you guys see my screen? Yeah. Okay. So I'm going to be starting. Okay. Calm down now. Like, I'm getting more responses now. Why? Okay. So I'm going to be starting now, and so someone got that already. Bumi said PyTorch. Yeah, PyTorch. That's the correct answer. So I don't know. Okay, Bumi got that already. Followed, but the rest doesn't count. So Oluwaseun, Emmanuel, you weren't fast enough. So I'm moving on to the next one. Are we ready? Moving on to the next one. Are we ready? Okay, so the answer is PyTorch. We got that. Okay, Michael, Ajiboye Michael got this. Okay. So just one person. You guys don't know this logo. I think we've said the name of this logo during one of the speakers' presentation. This was what this was the library Stephen Oni co-authored, the Danfo.js. Danfo.js is pandas for JavaScript. So I don't know if you guys know this library, but then I think moving on. So if you want me to move on, send a fire emoji to the chat section. So Bumi has 1 point and Michael has 1 point. I want to know if this shouldn't be only Bumi and Michael. Okay. Moving on. How about this? No one has gotten this. No one has gotten this so far. Pandas. Bumi got it. Like, I don't know. Bumi, what are you using? Are you using Jazz or what? Bumi got this. So Bumi has 2 points. Michael has 1 point. Tiami, you didn't type that very, very early. So Bumi has 2 points. Michael has 1 point. Moving on. Okay, this is the answer, pandas. Answer should be flooding the chat section. Precious. Okay, call only Precious. Precious was the first person to answer this. So Precious has 1 point. Precious is on the leaderboard now. So Precious got that. Oluwaseun wasn't fast enough again. Okay, so moving on. Yeah, this is Flask. Bumi got that. Oh, damn. I said the answer already. This doesn't count actually. How about this? Collab. Femi got it. Oluwafemi Abiono. Yeah, so Femi was the first person. So Oluwafemi Abiono is on 1 point. Bumi is on 1 point. Michael is on 1 point. Yeah. So I don't know, is this interesting to you guys? Are you guys fighting for this prize at all? How come Bumi is still on 2 points? Adewale Bakari, what's the problem? Okay, moving on. Okay, the answer is collab. How about this? This Tableau. Yeah. This is Tableau. Oluwafemi Abiono, 2 points. Femi is on 2 points. So Femi and Bumi, they are tying now. Moving on. Okay, Tableau. How about this? If you don't know this, you're not a data scientist. Oluwafemi Abiono is on 3 points now. He got that first. Oluwaseun Emmanuel, you're not fast enough. So Femi is on 3 points. Okay, moving on. So it's Jupiter. How about this? Oh damn. SQL. Abiono Oluwafemi, 4 points. Precious wasn't fast enough actually. Yeah, SQL. So Femi got this again. Femi is on 4 points. Femi is running away with this prize, oh guys. Femi is running away with the prize. Correct answer is SQL. So moving on. If you guys want to see the next one, type Paul, move on. Wumi is very desperate. She said, move on. Oh. Okay. So you guys should stop typing, I beg. Don't say it's spelled out. I'm moving on to the next one now. Git. Yeah, Oluwaseun Emmanuel. Finally, 1 point. Yeah. Femi Abiono was second. Like, what's your internet provider, Femi guy? So Oluwaseun is on 1 point. Femi is on 4 points. Femi is running away with our money. So the answer is Git. The answer is Git. Git. Yeah. It cannot be glue exactly. Femi can't be using glue. It's probably using something else. Okay, I'm moving on now. No answers yet. No answers yet. No answers yet. Kubernetes, Solo. Who's Solo? Yeah, Solo is on 1 point now. So just one winner. It's not Spider. It looks like Spider, but it isn't. Yeah, it's Kubernetes. Yeah, what's the pronunciation? I don't know. Yeah, so Solo is on 1 point. Femi is still leading actually. So moving on. The answer is Kubernetes. Yeah. So I guess that's the end. That's the end of the session. That's the end of the session. So congratulations to Femi. Femi won our credits. So Femi, reach out to yeah. So Femi, reach out to me or Grace about on your prize. So if you guys want to see a part 2 of this challenge, if you guys want to see a part 2, drop a fire emoji. I'll create a part 2 after the last last speaker. Okay, so Sani wants a part 2 of this. Yeah. Okay, so Precious wants to win also. Okay, so I guess that was a very interesting session. Let's move on to our final speaker. So unfortunately, Brain won't be joining us this evening because he something came up and he won't be joining us this evening. So although we promised 4 speakers, but now we'll be giving you guys 3 speakers. 3 speakers have no bad now. I mean, what do you guys feel? Yeah. So we'll be going on to the final session, the final keynotes. The final keynotes. Let me do an introduction. To the final keynotes. I'm coming, sorry. Stop sharing. Escape. Okay. Yeah. So give me a second and we'll proceed. Yeah. Yeah, so Brain will be joining us today. I said that already. Yeah, so our final speaker. I'm sure this face is very familiar already. You guys know this person. Even without even reading his bio, you guys already know his bio. Yeah, so our final keynote speaker for today is Elisha Odemakinde. We'll be talking to us today about pathway to becoming an AI engineer, or deep AI engineer. It's not even ML, it's not data science, it is AI. So welcome Elisha in the chat in the chat section. You guys know Elisha. You guys know how hot Elisha is. So drop fire emojis, please. Yeah. Let's fire emojis keep rolling. Yeah. Okay. So Elisha is an AI engineer at Parallels Core with core focus on edge intelligence. He's a self-taught AI researcher and an experienced engineer in sport analytics. So self-taught, that means Elisha understands the pain of learning programming all by yourself. He's a self-taught AI researcher. He's the founder of Data Science Ife, our community, which is a transition to AI plus OAU, and also a mentor to growing data scientists in Nigeria. yeah, growing data scientists, including me actually. So Elisha is also my mentor. Um, so if you see me blow in the nearest future, know Elisha gingered me. He's also known for some of the notable events that solidified data science in Ile-Ife. So events like Speak AI, I talked about Speak AI. I talked about Clean Code. Elisha pioneered that. I talked about Data Week. Elisha pioneered that, and more, and more events. He's passionate about growing AI communities in Nigeria to produce world-class data scientists and ML engineers. So Elisha is driving towards producing world-class. Okay, so once again, a round of welcome Elisha. Drop clapping emojis. Welcome Elisha. And so Elisha, I don't know if Elisha is there with us.
Hello, Paul.
Yeah. So I'll quit sharing my screen now, and Elisha will take the floor.
All right, guys. I want to believe you guys can hear me clearly, loud and clear, right?
Yeah, we can.
All right. I'm so excited to be here. I'm going to try and make myself as quick as possible because I know the speakers, almost all speakers have said, all the speakers, they've said, very awesome things, right? So just a minute, please. Let me share my screen. Sorry, can you guys see my screen? Which of my screen can you see? Because I have so many screens open here. I believe you guys can see the slide I wanted to share with you. Paul, can you see that?
Yes, it's still sharing. Okay, yeah, we can see your slides now.
Okay, cool. Okay, let me enter presentation. So I want to say I'm so excited to be with everyone here, right? I'll be talking about the pathway to becoming an AI engineer. Okay, just give me a minute. Let me just, start my stopwatch. I know that yes, I'm timing myself because I really want to ensure I stick to time. Okay. All right. So good. I'm so glad to be here. I'm so excited about the growth of the community. I'm so excited that, Paul is now, championing the community alongside Grace, Bumi, Amazing Grace, Dorcas, Precious, I can still remember those amazing names. So I'm so much excited to be here with you guys. So I'm just going to be sharing with you on some basic concepts, things that you need to know, right? I understand the feelings that a lot of guys have with respect to these things, right? So I'm just going to be straightforward with you guys, okay? But I just want you guys to follow and tag along with me. If there's somebody that needs to be here, please try and get the person here that needs to hear this, right? Okay, so I'll be talking about myself. I'll also talk about my story. That's the major reason why I even want to be. That's the major thing I really want to share, right? My story. Every other thing is something that you guys can, flow along with. Please, if you cannot hear me, please let me know. Paul, I believe you can hear me loud and clear. All right, good. So I'm sure a lot of people are so much excited to hear my story, but let me quickly talk about myself. I didn't even arrange this thing very well. Okay, so luckily I'm an AI engineer with Power School, and I currently lead a team of computer vision engineers where we solve problems around sport analytics. Then I'm a lover of music. When I mean lover of music, I'm actually a musician also. I play the guitar, drums, and the keyboard. When I get to talk to people like this, I always love to let people know the kind of person that is trying to talk to them. I love to travel a lot. Then I love to talk to people about technology, and I love problem solving. Before coding, before I ever think of saying I want to write codes, right? I like to solve problems. And when I mean solving problems, going to the board, analyzing how you want to be able to solve the problem or approach the problem, before you now move on to writing codes. Okay, my tech story. All right, so I'm going to make this very quick. And the reason why I want to share this, my tech story, right, is because I wanted to motivate somebody out there. And I've had the chance of having a lot of conversations with a lot of you guys, and I understand what you guys are going through because I once went through that, right? So I studied electrical electronics in OAU, of course, right? A lot of you guys know that. Of course, 5 years has not been, it has not been so much of fun, right? I got introduced, the first time I heard about programming, right, was when I was in part one, right? That is why I so much like guys that, start very early, So we are all fully aware of the curriculum and things, a lot of other things that, guides our learning process as students on campus. But it's very, very important that you had value to yourself and then you had a skill set to yourself, that speaks for you, right? So I started learning programming, but I didn't start active coding until I was in part three. No, sorry. I didn't start active coding until I was in part two, second semester. That was when I started active coding, learning Python, learning all those things alongside some of my friends that gingered me. It's very, very important for you to have friends that can ginger you, that can motivate you. Do you understand? Please, I love to receive, response in the chat, so that I know that, yes, you guys are following, tagging along with me. You can, once in a while, say one or two things, just to let me, know that, yes, you're following. All right. So I started active coding in part two. The community started, I think, yes, part two. Then I went ahead to, start attending conferences. One of the things that actually motivated, I was just like you guys when I was in part two, right? Just like you guys, just as you guys are also learning, everybody's learning. I'm also learning right now. I'm not even a pro yet. Everybody's planning to be a pro. So I started attending conferences, then going from conferences in Abuja, Lagos, and similar places where tech conferences are holding. I got motivated. I saw what people are doing. I got motivated. I got challenged, Then I made up my mind that I was going to build up myself. So luckily, during the conferences I attended a time, in my third year, right, I met, I've been writing, computer programs before then. So I met, what's his name? Kelvin Oyana. A lot of you might not know him, but he was once the chairperson of Python Nigeria. So I met him and then he introduced me to he told me that there was a boot camp coming up from Data Science Nigeria. All of us are, in one way or the other, we started, our journey into data science through Data Science Nigeria and the likes, So we owe it to them, right? So I got introduced. That was more or less like the second boot camp of Data Science Nigeria. But before then, I've been doing data science, but I never knew that there was Data Science Nigeria. Do you understand? I've been doing quite some amount of data science. Now I jumped into Data Science Nigeria, went for their boot camp, ate all the food we could eat, I'm sure you guys, those of you that went last year or last 2 years to boot camp, from there, I, got motivated, that no, I can't allow this to just live within me. There needs to be a community, right, in Ife, right? And that's the reason why we started in 2018. We started Data Science Ife in 2018. Actually, the community actually started, some months earlier. I mean, it never got pronounced, things were so difficult then, but, we just had to keep moving. So to cut the long story short, Data Science Nigeria, we started a community, we did a lot of other things, we did trainings, blah, 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 up till I finished, from Ife. And from finishing from Ife, immediately I wrote my final, it's very, very important you understand what I'm trying to say, because my presentation is very short, but I'm trying to pay more attention to my storyline so that you guys can be motivated. That's the most important thing. My colleagues have said a lot of other things that you need to know, to move on. So I'm just going to add a few things. So I got into, all through the time from 2018 till 2019, when I finished from school, I joined Data Science Nigeria. Since 2019, Dr. Bai already, I've been in good terms with Dr. Bayo since 2019. So we've been talking a lot. And he has been seeing a lot of things that we do in Ife, and he was like so motivated to bring us, let me come and join the Data Science Nigeria, team in Lagos. So I defended my final papers in February 10, 2020, and February 11th, I moved totally to Lagos. I resumed Data Science Nigeria, started doing some research, started doing a lot of things with communities, led some communities, blah, blah, blah. Then from there, don't forget, before then, I've been doing some data science, machine learning. I've been doing quite some amount of, computer vision stuff and the likes, but everything got more pronounced. I began to pay more attention to them, build up myself. One thing, the reason I'm saying all of these things is I'm trying to let you guys understand the way I was able to move in my journey. I'm not yet saying that, yes, I've achieved it all, but I'm just trying to say that at least you can, be motivated to keep moving on your journey, right? So I started, I got motivated from there. Alongside the fact that I was working with Data Science Nigeria, I got exposed to working with some international companies beyond, Nigeria, that were doing so much into computer vision. Some of you might remember the session I had with RoboFlow AI based in Boston, and some other companies like, articles I wrote and, technical things I did with companies like Fritz, Neptune, and some other big AI companies like that. So these are things that actually motivated me, right? So what exactly pushed me to getting into more serious with AI was because I've learned some fundamental things about data science, machine learning, right? Then I went ahead to say, okay, let me start working on projects. Now, I started working on projects. Then from there, I worked on, some projects like Python, Football that you guys might remember, and I pushed them out, right? And you won't believe, part of these projects, I've just, let me just say, I've really, really worked on some core projects like Python and Football, and those two projects have been making people reach out to me up to now. Now, why am I saying this, right? It's not because you are good, it's not because you are perfect, or it's not because you are actually up to the task as an AI engineer or as an ML engineer, right? You might not even get there before you actually get the job, right? But what I'm basically trying to say is I was able to take out my time and then build up these little projects, push them out on Twitter, push them out on LinkedIn. It's actually went viral, and I was so happy. I was even surprised. But believe me, 3 days after, somebody reached out to me. A CEO from Palo Alto reached out to me, and he was like, wow, this is great, blah, 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 this. And I was so excited. That was how I got my engineering role with Palo Alto. Do you understand? Now, what am I basically trying to say, right? As you move on in your journey, it's very, very important that you learn the fundamentals, right? Go through the process, right? Don't be discouraged. Go through the process, then work on projects, no matter how little it is. Work on projects and let your GitHub profile reflect those projects that you're working on. It is very, very important, because what gives people first impression about you is your projects, what you have on your GitHub profile and the likes. Do you understand? It was so funny to the extent that when the persons, a lot of companies have reached out to me just because of just little projects that I worked on, right? And all they were telling me was that the moment they saw my projects, they went ahead to check my GitHub to see the things I've done. They went ahead to check my Medium. They've seen the stuff I did, blah, blah, blah. They were just so excited. The thing is, the reason why I'm saying all of these things is when you work on projects, you push them out, you give yourself, quality value out there, people are going to reach out to you. But if you don't work on projects, you don't do the little things that you can do, and you expect people to come and reach out to you, it's not going to work, right? I have my reasons for, saying all about these things before, I start talking about how you become an AI engineer. Work on projects. I always tell everybody that I come across, work no matter where you are, no matter how busy you are, even if you are a financial accountant, you are not doing data science, you are just getting started in data science. Look at how you can apply or work on small projects whereby you'll be able to infuse data science with respect to your financial career. You don't have to be an engineer. You don't have to study technology. You don't have to be, you could be a medical, you could be in the medical line, you could be studying Agric, you could be studying Yoruba, you could be studying music. But the fact is, AI cuts across all fields. And you don't have to know engineering in order for you to do that. Everybody has fundamental knowledge with respect to maths. That is all you need. And you just need to build up on that. Okay, so that's just my little story, and I believe somebody out there is motivated. So all I'm saying is work on projects. Don't give up. Work on projects. That project, those little projects, one day, one time, they're going to, make people reach out to you. I can boldly say that because I've tested it, I've tried it out, and it has really, really helped me. Up till last month, people are still reaching out to me based on just the Pi football I just worked on. I've not even released some other projects that I'm even working on, right? But the little projects you release, you standardize, you release them such that people are going to appreciate it, right? It doesn't have to be big. It doesn't have to be complex, okay? So it's very, very important. I believe somebody out there is motivated. All right, so let me just move on to some other things about, I've shared the story about myself. Intelligence is basically, how do you actually become an AI engineer? But before I go into that, you have to understand, I gave some contents of what I want to, go through. You need to understand what is intelligence. You need to understand jobs that need AI engineers, right? I'm just going to break all these things down, move at the speed of light right now. So intelligence is the ability to acquire knowledge and skill. So now, one thing I want you to understand is the reason why we call it artificial intelligence, right, is because we are trying to mutate the actual form of intelligence. God gave man the actual form of intelligence. That's the reason why we're able to think, we're able to make decisions, right? Intelligence, you need to see intelligence as when a child is just born and how the child, went through so many processes before he became an adult. Before your father and mother can say, yes, you are actually mature to make some certain decisions, it's because you've actually gone past some certain age, or probably you've gone through some certain training and they can fully trust you. Your brain has been taught. We all have natural intelligence. Your brain has been taught through those processes and you can make those decisions, right? Now, it becomes artificial when you now make computers make such form of intelligence. So that is basically what artificial intelligence is all about. Now, an artificial intelligence engineer is basically somebody that can mimic artificial, intelligence of the natural human intelligence and impute into computers, give computers the ability to mimic the functionalities of man. Do you understand? Now, I don't want to go so deep into that, but I just want to make that clear, right? So, but I want you to understand, right? You can be an AI engineer, irrespective of the job that you're doing. Whether you are in law, whether you are in agric, whether you are in any field you are into, you can be an AI engineer. And one thing I want you to know that AI engineering is not just limited to just building intelligence. As long as you are incorporating intelligence or mutating intelligence into computers, making computers to make actionable decision and insights from data and informations, you are basically an AI engineer. But, and AI engineering is just in different grades. An AI engineer can also be a robotic scientist. It could be a big data engineer. It could be a Power BI engineer. It could be a data scientist. It could be an ML engineer, a product manager, an AI researcher or scientist. Do you understand? But I'm just trying to let you guys know that AI engineering is a very broad thing. It requires a lot of things, right? But you can be focused. But, amongst all of the things that are listed here, one of the things I say I'm much more in line to is more of the robotic scientist, right? It's not like I don't do all of this here, right? But I'm much more of the robotic scientist, ML engineer, and AI research scientist. That is more of the kind of personality I want to have as an AI engineer. All right. Now, your background study doesn't matter. Whatever your background is, whether you're studying music, right? There is application of AI in every field. There is application of AI in every field. There's even application of AI with respect to biological neurons. You guys need to check out what we call spiking neural networks. I once gave a talk regarding that in 2019 at PyCon Nigeria. Spiking neural networks is a biologically inspired neural networks, and it's artificial. But the way it works, you're going to think like you're going to think like human beings just built up a real brain cell that God, built. That's the way it works. It's awesome. And the way people use it, it's far more than the way we think right now. Your background study doesn't matter. Whether you're studying biology, you are doing anthropology, you are doing all of these things, you are doing farming, you are doing, you are rearing dog, you are rearing sheep, whatever you are doing, it doesn't matter. The most important thing is look at how you can apply AI or how you can infuse this thing to what you're doing. That is what makes AI so much fun. But forcing yourself into another field, right? Let's say I'm an engineer right now. Of course, I can apply AI to health. I can apply AI to so many fields. But right now, for example, I can apply AI to law, but I don't have domain expert, right? In law. I'm not a domain expert in law, right? It's going to be stressful for me to force myself and just say I want to be an AI engineer focused on laws, how we can enhance laws and how we can reduce criminal activities, with the use of computer vision, natural language processing, and the likes. But I'm more of an electronic engineer. That's the reason why my AI is targeted towards edge intelligence. Do you understand? So you need to let the AI you're trying to learn, you can infuse it into anything, but you should target it to what you are so much interested in. If you are studying biology, look at how you can apply AI to biological systems or generation of biological systems. You'll be surprised that AI can learn how to, move how chromosomes, it can auto-synthesize chromosomes. Their architectures, see, you guys need to check out research works. People are doing awesome things. Their architectures, there's what we call genetic neural networks that can even help you, model the actual systems of human chromosomes and the likes and so many other things like that. Applications varies, but you need to focus on, you need to, channel your interest. All right, so requirements to be an AI engineer. An AI engineer is basically someone that is a software engineer, someone that loves to work with data. You have to be a software engineer, you have to be a data engineer, and you also have to be a machine learning engineer at the same time. That is what an AI engineer is. So software engineer in the sense you need to be able to build softwares. You need to understand, you might not necessarily be building so much of softwares, but you need to understand how softwares work. Do you understand? And you need to understand how to engineer data, how to process data, how to, recently I was working on a particular data for a particular company, and I was trying to annotate some type of data. Then I was trying to train the model to be able to identify certain things, right? I was building an AI that can identify certain things and give us inference, give us a precise location of where it was able to see those things. Now, I noticed I had to gather about 3,000 images, let's say almost 6,000 images, annotated them myself, right? But the funniest thing is I noticed that my data was a little bit biased. So the dimension in which I was annotating wasn't corresponding to the actual real world scenarios, right? So when I was training the model performance was not so good as expected. Then what I did was that I had to balance out the data, ensure that the data was kind of very robust, add, some extreme cases of the data of the actual system it's going to be predicting, and the less extreme cases of how the system is going to be. And when I trained the model on the data reduced from 6,000. I reduced the data from 6,000 to about 2,000 images, and I trained the model, and I had far much more greater accuracy. So it's not about how large the data could be. It's not about how large the network or how deep the network. Sometimes we as engineers we stress the neural network. We think neural networks are wizards. They are not, right? They are not. So sometimes the way your data is structured also affects the way the model is going to be like. But that's the reason why it is more important for you to pay more time to problem solving, having the thought process, thinking about how to solve the problem than writing codes. Writing codes should be the last of your thoughts. All right. So what are the fundamental things you need to know about to be an AI engineer? You need to understand that you need to fall in love with math, at least love math. You don't need to know so much of math, but try to love math. I know a lot of people don't like math, but it's not compulsory, but it's going to let you go far as an AI engineer, okay? Learn languages like Python, JavaScript, TypeScript. Don't be streamlined to just learning Python. I need to emphasize that. Don't be streamlined to learning Python, right? I would encourage you to learn stuff like JavaScript, or learn how you can, implement, build scalable systems with respect to, things like JavaScript. Though Python is the standard for AI, but I don't want you to also think you can't just learn other things. You can even learn C++, learn all those things for AI, but I would recommend know Python very well and also know JavaScript as if you will not know anything else. Those two languages, be crazy about them to be an AI engineer, okay? The reason why I'm saying that is because by the time you're trying to build scalable systems, I've had the chance of building scalable systems with teams, and I was able to see the importance of JavaScript. I was this kind of person that was always writing Python, but when it got to some stage, of course, Python can get everything done. But there are some times whereby you just have to leave some stack and then go for the best, the one that can deliver the best. It's not like Python cannot get the job done. Python has almost all the libraries you need to be able to do anything, right? Deployment, blah, 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 interaction with blah, blah, blah for front ends and the likes. But the truth of the matter is scalable systems, for interactive systems and, all those flexible, whatever, of course, those things are being built in Python, but don't streamline yourself to Python. Learn things like JavaScript, TypeScript, and then follow current trends in technology, right? Also learn how to write codes efficiently, be optimal in the way you write codes. Now, the reason why I say this is I've had times of working with very large GPUs, remote GPUs, virtual machines, and the likes, and I know what it takes, right, in order to be able to, there are some levels whereby you get to whereby it's not just about writing the code. You are much more concerned about how fast can your system be. Now, if you have two engineers, one can write code, the other can write, two of you can write code, you can get the job done. But the fact is, in order for your system to scale, in order for you to have optimal latency, for quick response to your users, the users of your AI systems, right? You need to consider how efficient your code can be. Some codes are more efficient than the other. Code efficiency is very, very important. And code efficiency can also affect your computational speed. If your code is efficient, that would require the GPU to consume less of data, and that would cost your company less money. The implication of just this little, it can ruin your company, and it can also make your company. If you are very wise with it, it can make your company a lot of money. But if you are careless about it, you just write code, you are not optimal about it, it can ruin your company. So they are very, very important. When you are writing codes, learn how to write codes efficiently. So your data structures and algorithms have to be top-notch as an AI engineer. So if you want to grow as an AI developer, learn how to use Stack Overflow, take your time to read Medium articles, write about the things you learn. That was the way I was able to build up myself. I wrote about the things I learned, okay? Work on little projects. I need to emphasize that. Projects, see, if you come and meet me and say you want to learn data science and you are somebody that you just want to learn, you are not working on projects, and later you come and meet me, sir, I'm looking for a job, I won't even answer you, because the truth of the matter is I'll see you as an unserious person to have learned and not be able to apply what you've learned to solving problems. So please work on little projects, no matter how little it is. If it's that the thing should just translate from Yoruba to English, work on it. And whatever projects, a lot of you guys have projects that you have worked on, you've just left them there. Go and revisit them and complete them to the level whereby people can assist you. You don't have to know everything. You can collaborate with people and say, oh, guy, I need you to collaborate with me to work on this project with me, right? Find a trustworthy person to work with you on a project. Don't just get any person that will just steal your idea, okay? So work on the project, get the project out. In fact, you can celebrate and say, oh, myself and this guy worked on this project, we built this together. That is the goal. But you trying to work as a lone ranger to build everything yourself, build the front end, build the back end, you discover that you get frustrated with respect to time. But when you work with people on projects, you get to achieve the goal and you get to celebrate it. And before you know it, people are going to say, yes, you have the skill. You have what it takes to be an AI engineer. Or you have what it takes to be a machine learning engineer. Or you have what it takes to be a data scientist. It's very, very important. So be part of a vibrant community like AI Plus OAU. Believe me, a lot of things are about to happen in the community. So many things that you guys are going to be so much excited about. So you need to be very active. You need to be very, very active. Collaborate with people, learn how to build microservices, APIs. Start by learning how to build endpoints, learn how to build APIs, little by little, all those your gets and the likes, learn how to build all those things before you now move on to say you want to build a microservice that people can use out there. Okay. I have a taste of DevOps engineering. My colleague, Okoyemi and friend, he has, done justice to that. You need to understand DevOps. It's the current state of the art thing. Don't just think, see, people are going to appreciate you if you're an AI engineer that also understands the DevOps process. But people will not appreciate you if you're just an AI engineer that just know how to solve problems, but you do not know how to implement or make it, scalable, right? DevOps makes your system scalable and, reusable. It's very, very important. And I have had my experience with DevOps and I know what I'm talking about. So you need to know that. It's very, very important. Get familiar with version control tools like GitHub, GitLab, Git Bash, and all those things. It's very, very important. Okay. I'm going to share this slide with you guys, but, So in conclusion, AI is fun and experimental, but you need to stay motivated, right? There is no better way to motivate yourself there's no better way to keep moving than to motivate yourself. And one of the ways by which you can motivate yourself is to also have people that can work with you on this project. And that's how you get, that's how you get through the process and you become a successful data scientist, a successful ML engineer, and a successful, AI engineer. Also, it's very, very important that you read up research papers, check out what people are doing out there. Don't be limited by what people are just doing within your country. People are doing crazy stuff. I see no reason why we cannot build a robotic engine or a robotic something like what's the name of this robot that I know you guys know the names of all these robots that people are building. There's nothing stopping us from building that. We can. Of course, we are always shouting we don't have money, but the little that you start with makes people see the potential in you that you can actually do it, and that is what gets you the job. But if you do not show the potential by working on little projects, they will not even call you. If you send your application letter, they will not even read it, even if you have the task. But the truth of the matter is you did not present yourself the right way. So present yourself the right and acceptable way so that people can patronize you and recruit you and get you the job. Data science and machine learning and AI should be one of the easiest jobs you can get. But if you don't work on projects, you keep thinking data science, machine learning, and AI is the toughest thing, and you'll keep running away from it. So get yourself working on projects. Little projects gets you that dream job. People are going to see it and they will appreciate it. Okay? Somebody will definitely see it. Leverage on the use of your LinkedIn, leverage on the use of your Twitter, leverage on the use of your networks. Don't just post random things so that when you are posting serious things, people will take you serious. All right? So that's all I can say. Thank you for having me. I want to believe you guys learned a lot of things. Paul, thank you.
Yeah, Elisha, thanks a lot. We should be telling you thank you. It should be the other way around because every time I listen to Elisha, there's always that feeling I get of, oh, Paul, you aren't doing enough. Yeah, so I think you guys can reflect on what you've been doing actually and tell yourself you haven't been doing enough. And after this, you probably want to double up and do better. Yeah, so some people are already thanking Elisha already. So I want everyone to if you can drop an emoji, if you can drop whatever you can drop in the comment section, show appreciation to Elisha. Yeah. Yeah. So you talked about sharing your work, because if you don't share your work, no one knows that you do stuff. So yeah, so like it's just more like marketing yourself, and people get to know about you. You also talked about knowing mathematics. Okay, so because fine, you want to do data science, your tutorials may tell you that, oh, you don't need to know this math, you don't need to know too much of math, blah blah. But in the real sense, if an AI engineer is telling you right now that know your mathematics, and I think you should hold on to that and probably get better at maths from now on. Someone is asking if we are going to be giving the slides. Elisha will definitely be sharing the slides with us. Um, and I think one other thing I picked up was data science and data structures and algorithm. I picked that up, and yeah, it's the sooner the better actually. So the sooner you start working on data structures and algorithm, the better you get at it. Yeah, so thank you, Elisha. Thank you, Elisha. So do you guys have questions? Fine, the section was awesome, but you guys should be throwing questions already. So what are your questions you have? We'll be going straight up to we don't have. We'll be going straight to question and answer. We'll be going straight to question and answer. I was hoping other of our speakers will be around, but I guess they aren't. So Elisha is on ground to answer all your questions actually. So what questions do you have for Elisha? Q&A. I'll open the Q&A now, and I've not seen any recent question, no, guys. You guys don't have question after everything Elisha said. Um, yes, no questions, no questions, no questions. I was expecting like once the session is very awesome, there'll be a lot of questions. Yeah. So in the absence of no questions, actually, what I want to ask is okay. Someone is okay. I just got a question now. Someone is asking, please, for someone that wants to go into education aspect of artificial intelligence in Nigeria. No, for please, for someone that wants to go into the education aspect of AI as a Nigerian, how will I go about it? So this person wants to go into the education aspects. Do you want to be taking courses on AI, or I don't know if Elisha has an answer to that.
Okay, so can you hear me?
Yeah, loud and clear.
All right, so you said the person wants to take educational courses with respect to AI.
Yeah, the person wants to go into education aspect of AI.
Okay. So it's okay. How do I put it? How do I put it? Let me just say the closest to this is, data science Nigeria has um this education thing that you're trying to do. That's a very good way to start, right? Now, but that's a very good way to start actually, seeing how they get things done there. But let me just say on a personal basis, how do you go about it? Now it depends on the kind of educational stuff you want to do, right? So let's say you are this kind of person that just want to be educating people, right? And you want to use AI to educate people, right? One of the things you need to know is, of course, you need to understand the fundamentals of AI, right? Learn the fundamental concepts of, education also. Now, you need to also think of,
Okay. Elisha, the person is sending a follow-up saying like going for graduate studies. Oh,
oh,
no, sorry. I think it's a different. I'm getting anonymous questions, so I'm mixing things up. Okay, I guess you should just conclude on that question. Let's move on to another. You're saying
okay,
something.
yeah. So in order for you to actually, get through this educational thing, what you need to understand is education is actually a very broad thing, right? It's a very broad thing. What you need to understand is, okay, for example, let's say it's just, you just want to be able to work on work on teaching people how to read, or look at how you can enhance reading mechanisms. You can build applications that can enhance reading mechanisms for people. That is basically trying to educate people, right? Now, people that get to use the hub can get educated about it. But the funniest thing is, most of the people you are trying to educate, of course, education is not limited to whether you have a smartphone or you do not have a smartphone, right? Even people that have smartphones still need to be educated about some certain things. Now, it depends on what you want to educate people on, right? You can always think of how you want to approach the problem to educating them, right? If it's that you want to build an application that can put people on how to educate, and such that the backend engine is fully running on AI, that gives people suggestive measures of how they can, flow into AI, or how they can, get those, how they can get educated or get notified or get corrected. For example, now, let's say a lot of people have smartphones, but some people break traffic rules. Do you understand? Now, those that break traffic rules, are we going to say they are uneducated? A lot of them are even educated. Some are not educated. Some are educated. What if you build an application whereby you're just able to, once the traffic light shows, it gives them an interpretation of what the light is. You can build educational apps or educational platforms that can give people interpretation to the actual meaning of certain things that they often get misconception about. Do you understand? So I would say you need to start by getting into AI first, get fully deep into AI, and then see how you want, see the educative part that you want to solve. You need to know what you want to solve in the education is a broad thing. All right. So that's all.
Okay. All right. So moving on to the next question. What's the best? The person is saying, what is the best advice to someone just starting out in data science? If I am to answer that, I'll say, just as Elisha has been hammering on, he said, projects. Yeah. So that answers it, I think. Is there any other thing Elisha wants to add?
Of course, you said it, right? How do you start? Do you understand? One of the ways by which you can, get through this thing is, number one, work on projects. But before you work on projects, you need to, first of all, join a vibrant community. That's why I'll say, be an active community member in data science Ife. I'm sure a lot of you guys are from Ife, right? If there's no active community in your community, in your school, if you are not from Ife, if you're not active, at least be part of the Telegram channel, the Slack channel of Data Science Nigeria. Be active there. Ask questions. Collaborate with people. Reach out to people that can, put you through or guide you, and don't waste their time. One of the reasons why I don't accept mentoring people, right, is because a lot of them want to learn, but I don't see the passion in them learning. It's like they just want to suck and they just want me to be pouring. But if you want to learn from me now, I don't expect me to be pouring. I want to also see the value I can get from you. I'm not saying monetarily. I'm not saying, when I mean see the value I can get from you, I want to see what are the other things that you are good in, that can be of value to yourself. That is value to me. You don't necessarily have to add value to me, but I need to say that yes, you are adding value to yourself. Do you understand? And that is the way it starts from. So get vibrant in the community that you are in, participate in the project of the community, work on projects, look for people that can collaborate with you on an idea or whatever. Do you understand? And another thing is get a mentor. Get a mentor. Paul is there. Paul can mentor you. Bumi is there. Bumi can mentor you. Precious is there. She can mentor you. Grace, Dorcas, Amazing Grace, Felix. These are people that can mentor you in your journey to be an AI engineer, all right? Or to be whatsoever you want to be, because they've actually, at least, they have little experience or they've gone through all these things. So they can basically give you an idea of, oh, do it this way, do it that way, don't do it this way, don't do it that way. Okay. So I would advise you go by that. So that's all I can say.
Okay. So there's a question here, but I'm guessing that question was for Opeyemi. I'll read it out though.
You can let me answer the question.
Okay, he's saying in NLP,
Yeah.
like Twitter feeds being streamed, how do you save and also make it like refresh at real time for each time you run the project afresh? Like, I don't know. Okay, let me read it again. Also in NLP, like Twitter feeds being streamed, how do you save and also make it like refresh at real time for each time you run the program afresh?
Okay.
For this, I think you should, if after Elisha answers, I guess, reach out to me so I can link you up with Okwe, or so you can probably have a you guys can have a conversation about what you really want, because I think this person is very, very specific and probably there's a project the person is doing. Yes,
All right.
okay, Elisha.
So now, okay, before I go ahead and say that, so guys, I've dropped the link to the slide I just shared with you guys. You guys can access the link in the chat session. I'm sure everybody should be able to see because I sent it to both panelists and attendees. All right. So now, to answer that particular question, right? MLOps, DevOps, does the automation for you, right? For instance, okay, let's say you deployed your app to Heroku. If you follow the Heroku documentation now, Heroku has an MLOps pipeline, whereby they take out your work from your GitHub. You need to push your work to Git. That's, if you don't know how to use version control systems, you have problems with that, and you might not be able to use it. Now, you push your work to Git. Now, Heroku has a means of communicating to your Git. It requests for authorization into your GitHub, right? Then once it gets the authorization to your GitHub, it requests for what is the name of the repository. Then it will have given you some guidelines of what you need to add to your repositories in order for it to build up your project and then make it, scalable, and people can basically use it. Now, after requesting access to your repository, right, what Heroku helps you to do, right, with its MLOps platform is that it also runs some certain type of build on your work, right, in your GitHub page. And then it also runs the command that triggers the application on your GitHub page. Every dependency is needed to run that thing. It helps you to host it. And then it also tries to give you the flexibility of clicking on deployment. Once you click on deploy, it will generate a unique link for you, which is an endpoint or a microservice. Now, whenever you make changes to your GitHub, all you need to do, or let's say you've updated it, right? Or like Heroku, right? You can set automatic redeployment so that whenever you make changes to your GitHub, it will automatically fetch the changes from your GitHub, and it will make those changes with respect to the front end, or the access, whatever the users are accessing, it will reflect directly. So you just need to just keep making changes to the GitHub, and everything will reflecting in production. You understand? The same thing goes to AWS, GCP, Google Cloud Platforms, and all other MLOps platforms like Azure ML. They can help with your automation. So DevOps, the most important thing about DevOps is automation. So if you are concerned about automation, right, DevOps gets it done for you. So you don't need to bother about doing it yourself manually. DevOps helps you to do those automations yourself. Okay? So that's all I can say about that.
All right. So I'll be moving on to the next question. Someone is asking, how do I leverage on CMS platforms in deploying of my models, as I know both CMS and deep learning? Okay, so if I'm to answer this, I'll probably give this a shot before throwing it to Elisha. You have experience working with, say, WordPress or WordPress. The most popular one I know is WordPress. So one thing you can do is, I don't know if you, because you can tweak a lot of things you doing working with WordPress, but I don't know if you can do a lot at the back end using WordPress. I don't know. So what you can do here is try to figure out how things can be done on the back end so that you can integrate it with probably an API you built using Flask or Fast API. So the CMS, you can use the CMS to build the front end, then link it up with something at the back end using either Flask or Fast API. Okay, so Elisha, what do you have to say to this?
All right, sorry, what? I didn't get the question the other time.
Yeah, so the person is asking, how do I leverage on CMS platforms in deployment of my models, as I know both CMS and deep learning? So yeah,
Yes.
CMS, yeah, I think you
Right.
can.
Oh, answer the question. Answer the question.
No, I think I answered already. I said there's a lot you can do. There's a lot of tweaking you can do, say with WordPress, but I don't know how much of it you can do on the back end, because I'm not too familiar with WordPress. But I'm saying you can use that to build a front end, say WordPress, and do your back end with either Fast API or Flask. Then both of them can work together. So your WordPress will build your front end, and Fast API or Flask will build your back end. So I don't know if that answers the question, Olusegun Banji. You can drop a comment. You can drop an answer, something in the comments. Okay, so moving on to the next question. Also, please, can you share what is meant to have an asynchronous video interview? How is the interviewer like or conducted? So this person is asking about asynchronous video interviews.
Okay.
Yeah, he's asking how is the interview like? Probably, do you have an experience? If is person is assuming you have experience with asynchronous video interview. So yeah,
Okay.
in an interview where the interviewer is not present.
Okay. So he's asking what's he asking about when the
Yeah,
interviewer?
he's asking that. So I'm assuming that okay, the person has an interview,
Okay.
an asynchronous interview that is a video interview, but your interviewer is not. Yeah, he's interviewer. Yeah, the interviewer is not there. So you're just going to answer a bunch of questions and leave the video interview. So a person is asking if you have an experience with that. Probably you can give the person interview advice or something like that.
Okay. So you're basically trying to say the person has an interview, the interviewer is not there, and he needs to answer some questions from the interview. So
Yeah,
basically the person is asking how
asynchronous. Yeah,
questions.
yeah. Like, do you have tips for the person?
It depends on the questions now. But okay, if you're an AI engineer or you are preparing for an AI engineering role, follow everything I've said, in the slide.
Okay.
Follow everything I've said. You should be able to answer any question. At least if you are not so close to answering the question, if you are not so accurate in answering the question, you should be very close to answering the questions. Do you understand? So almost all questions they want to ask is relating to version controls, relating to your experience with MLOps, then your data structures and algorithm. There was one time I had to do an interview like that. It was more data structures and algorithms. Then it depends on whether it is technical or non-technical. But at the first stage, let's say you're trying to apply to Google now, the first stage is always very technical. They want to see if you actually know how to write codes. Now, when you get past that stage, they now want to know, okay, what are the skill sets you have? What are the projects you've worked on? So the truth of the matter is, if you are applying to places like Google, they are not concerned about how well you can write code, right? Do you understand? But if you look at you can have like about 5, 6, 7 interviews before you actually get to the final stage. And whereas the first stage is more or less like you're writing code, the other stages are more or less like what you actually know, like how well you know them, how well you can leverage your resources. It's also very, very important for you to know how to work with open source tools or contribute to open source tools. These are things that can actually help you to get the job. So let me just stop there. Don't let me say too much. So
Okay. So in the comment section, Amina Madia. Yeah, Madia is community manager for Data Science Nigeria. So she's in charge of all the AI plus communities in campuses. She's saying in the comment section, still on this asynchronous interviews, she's saying it's an interview mostly done with a bot. In other words, it's automated. So the key is that it's preparing for common interview questions relating to the role applied for and general interview questions. So since you'll be interviewing, it will be a bot. So the bot will probably ask you common interview questions for that role. So you want to just get familiar with common interview. If it's a front-end ML DS role, get familiar with the common questions in that role. Yeah. So I think that answers it. Someone was asking, how much of mathematics do you need to know? Like what aspects specifically?
All right, so you don't need to know so much of maths, but very, very important that you love maths. Maths is not going to, is not everything, right? But there are some stages whereby it's not just how to write code. You need to now start infusing some sort of mathematics to make some sort of type of decisions, calculations and the likes. Recently I was working on a project whereby I had to interpolate the location of an object I'm trying to detect with respect to another object I'm trying to detect, right? These two objects are located on this image, on this video frame, right? But I was trying to make a decision, right? If it was, don't let me say too much about that. But the decision was based on their locations, right? Now, based on my little knowledge of mathematics that has to do with Euclidean distance, I was able to solve the problem, right? Just by understanding what Euclidean distance is, straight line graph, all these interpolations, blah, 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 blah. Now, it can really help you, right? There was even a point where I had to make a decision of if a particular box was inside a particular box. Now, there's no way you can actually write, for you to write that kind of code, you need to get the coordinates of some certain things, then make some decision process. If this is this, that, and then if this box is within this box, dimensions, blah, 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 is this, is that, then it's most likely inside the box. If not, it's not. Now, imagine you do not have mathematical backgrounds or whatever. You might not be able to solve the problem. It might be very difficult for you to solve the problem for your company. Do you understand? So it's very, very important you stick to, you at least fall in love with math. You don't need to know math to start. You can be learning it little by little, progressively along the line on your journey. Okay?
Yeah. Okay, if I'm to chip in a little here, for mathematics, I'll say you should learn, to be more specific, your linear algebra. So working with matrices, because deep learning or ML is basically you likes. So linear algebra is very important. Calculus is very, very important.
So for example, let me just quickly in this. Paul, can you hear me? Sorry, can you guys hear me?
Yeah, those are the two I can think of now.
Paul, can you hear me?
Yeah, loud and clear. Yeah, I can hear you.
Okay. So let me just quickly say something about that. Like he mentioned, linear algebra, matrices. That little word, matrices, right? The wonders matrices is doing is more than the way you guys think, right? With matrices, all these cofactor, determinants, and all those things, the little things, all these adjoints, cofactors can help you solve in real world problems is bigger than what you're actually learning. It's just that a lot of tutors or teachers, when they are teaching all those things, they're not teaching you the application of all these things. But believe me, you need to know all those things. If you know all these things, you can save your company a lot of money. Okay? And for you not knowing it, you can make your money lose a lot of money. Do you understand? So, for example, now there was this course in electronics that we took that has to do with signals and systems. For example, whenever you are trying to process video streams, it's a typical example of signals. But nobody understands, right? A lot of us were just reading signals and system, differential this, blah, blah, blah. When you differentiate a function, the effect of differentiating a function, right? We do not even know the implication. Functions are basically images. They could be images, they could be anything, they could be video, they could be anything. Now, the implication of differentiation, nobody knows. But the tutors will not teach you that. But when you start seeing all this application of all these things, and you begin to appreciate AI. AI is very, very applicative. So I would want to say.
All right. Okay. So I think without wasting much time, that rounds everything up. Actually, that rounds everything up. I'm seeing a bunch of interview questions here, but I'll just say if there's an interview question here, Elisha has probably talked about things about you. I've probably given you answers in. So I want to thank Elisha for coming around. Elisha has always been around, so it's not like he's coming around. So Elisha is reach out to Elisha on our group page. If you're not on the group page and you feel you don't want to miss out on the slides and everything, either you follow us on Twitter and we are going to be sharing a Google Drive containing the slides, or you send me a message on WhatsApp. I'll be dropping my Okay, so to round up, I think we've everyone here has done a good job by staying till the end of this program, and I think I promised a part up. Are you guys interested in rounding up this with the logo game part 2? Oh, guys are not interested. I guess we should just close. Okay, I'm not even getting. Okay, only Bumi is interested. Okay. Daniel Oladipo is interested. Okay. So calm down. So in about, this one is very short. In about 5 minutes, we should be done and round up the whole event. So I'll be sharing my screen now. I'll be sharing my screen now. No, not this. Stop sharing. Yeah. Okay, so you guys can see my screen, right? Yeah. Okay, so this one was what you said the answer to this. This was Kubernetes. So who has the answer to this? TensorFlow, like only Precious. Wait. Okay, someone is saying Glue. Yeah, Glue can be Glue can serve as your village people actually sometimes. So Precious has 1 point. Ebenezer was not fast enough. Yeah, so I'll be moving on to the next one. Next one. How about this? How about this? MongoDB, yeah, Bumi has 1, Precious has 1 point. Yeah, so MongoDB is MongoDB. Oseni Sakara, you're not fast enough. So Bumi has 1 point. Precious has 1 point. How about this? This is not ML related or anything, but React. Yeah, Peter. Peter is the first one on this one. Okay, so Peter has 1 point also. Moving on to the next. Everybody should be clamoring, shouting this one. Docker. So Precious has 2 points. Docker. How about this? Precious again. AWS Lambda. Okay, so Precious has 3 points. Okay. How about this? This nobody. No answers yet. No answers yet. Is it network or nobody knows this? Nobody. Wow. You guys don't know this, really? This is Open TV. This is Open TV. You guys don't know Open TV. Yeah. How about this? How about this? This quickly. The letter is already screaming the name already. Neural nets, wow. Um, yeah, if you can, no, not next, yes, nah, no neural nets. It's the panda's twin, NumPy. Yeah, Ebenezer got it. It's NumPy, NumPy. So it's not very popular, sha, but this is NumPy's logo. Yeah, I think that ends it. Yeah, so Precious is the winner of this round. So I guess that's where we conclude our game. So guys, thanks for sticking around. Um yeah, so thanks for coming around, and we come to the end of our conference. So if you want anything, please send me a message now. And if you have any questions or you want to access the materials, also send me a message. So guys, thanks. So I'll end the call now. And yeah.